All right, people. I believe everybody is doing great, nice, and absolutely fine. So, welcome to Unacademy Neet English. Welcome to Unacademy Neet English. Okay. I believe all of you are doing great, having a good time. So, guys, we have the next session that is complete physics part 2 and I would want you guys to tell me in the chats if I'm perfectly audible, if I'm perfectly visible, okay? Light up the chats with the fire emojis, and most importantly, do smash the like button because liking the session is extremely mandatory. Liking the session is extremely mandatory. Keep that thing in your mind. Okay? Okay, liking the session means marking the attendance. And one more important thing I just want to say. A lot of people are saying, sir, what about 11th part 2? After this marathon, I'll be taking the 11th part 2, okay? Because I was making the slides for that particular session, okay? I couldn't complete those slides. That is the reason I thought I should complete this part first, okay? Then I'll go on to the 11th part 2. Keep that thing in your mind, okay? Now, don't ask me again and again. So I'll be taking that up this marathon because slides were not complete, okay? I was making the slides, that is the reason. Okay? And guys, most importantly, smash the like button. Liking the session is extremely mandatory. And when it comes to this particular session, that is complete 12th physics part 1. How many number of chapters we are going to cover in this particular session? Let me just show you. When it comes to the number of chapters, we have got electrostatics, we have got capacitors, and if you ask me, sir, how many number of questions are asked from electrostatics, we say 5 questions. If you ask me how many number of questions from current electricity, 5 questions, okay? From this portion, even you can say from this portion, you can expect 4 questions. And from this portion, you can expect 2 questions, 2 to 3 questions. So we say this is extremely important. We say this is extremely important. Okay, so my dear friends, 1, 2, 3, 4, 5, okay, 5, 6, and 7. 7 chapters we are going to finish in the today's marathon. So I would want you guys to call up your friends so that we can complete this together, okay, so that we can smash all of these chapters together, okay, in this marathon over here. Is that clear? Shall we start? Shall we start? And guys, smash the like button. Smash the like button. That is extremely important and mandatory. Okay. So I think we need to start this particular session over here. Let's dive into the session and let's start this particular session. So let's start with the chapter 1, that is electrostatics. Extremely important chapter, okay? Extremely important chapter. So I will be starting from the scratch. If you have not studied these chapters, okay, doesn't matter. I will be starting from the scratch. You would be able to understand every single thing, that is for sure. Now guys, take a look, take a look. Here it is mentioned over here, the first topic when it comes to the electrostatics, that is electric charge. What this charge is all about. Let me just give you the basic idea of charge over here. Guys, let's suppose you have a comb, okay? You are rubbing this comb with your hair, okay? Then a small piece of papers are placed over here. Small piece of papers are placed over here. When you take this comb near to these piece of papers after rubbing with your hair, what is going to happen? We say these piece of papers will be attracted towards the comb, okay? Now, if I say, before rubbing this comb with your hair, if you have taken this comb near to the piece of papers, it will not attract these piece of papers, okay? So means after rubbing only, these piece of papers are attracted to the comb. These piece of papers will stick to the comb. So can I not say, when you rub the comb with your hair, something gets occupied on the comb, and this something is what we call the charge. And due to this charge only, it starts attracting these piece of papers. So my dear friends, I can say charge is something due to which a body shows electrical and magnetic effects. Charge is something due to which a body attracts other body. Like, when it comes to the charge, we say it is of two types. You have got positive and we say negative. Let's suppose, my dear friends, you have got a rod over here, okay? You have got another rod over here. If you place, let's suppose positive charge on this rod, if you place positive or charge on this rod, we say the two rods will actually repel each other, okay? The two rods will repel each other. Now, my dear friends, if you place, we say negative charge on one rod and negative charge on another rod, we say these two rods will actually repel, because we say like charges repel and unlike charges attract. And my dear friends, if you place, we say positive charge on this rod, and if you place negative charge on this rod, these two rods will actually attract. So when you are placing the charge on a rod, then only we can feel the attraction and repulsion. Then only we can see, we say, the magnetic effects over here. So can I not say charge is something due to which a body shows magnetic effects, due to which this comb attracts these piece of papers. Okay, that's it. This is the basically definition of charge. This is how we define charge. And we say when it comes to the symbol of charge is Q and SI unit of charge is Coulomb. Okay, we say, let's suppose on this rod Q is equal to 2 Coulomb charge. Okay, so we say Q is the symbol and C is the SI unit. Okay, now my dear friends, take a look over here. Let's move on to the Coulomb's law. Take a look. Let's suppose you have got a charge over here, that is positive charge. You have got another charge over here, that is this positive charge, Q1, Q2. Since you are placing the two charges at r distance, we know that whenever the two charges are placed at some separation, these two charges will actually repel each other. Okay. With the force, that is what we call the electrostatic force. If somebody asks you, how much is the force between the two charges? Directly remember, sir, this force is K, Q1, Q2 divided by R square. Q1 is this charge, Q2 is this charge, R is the separation between the two charges, K is Coulomb's constant. Now, if I say, what is the value of this K? Sir, this K is further equal to 1 by 4 pi epsilon naught. This epsilon naught is what we call the permittivity of free space. And value of this epsilon naught is 8.85 into 10 raised power minus 12. Then we say Coulomb square upon Newton meter square. This is the value of epsilon naught. And if you put this epsilon naught here, then you solve this. K will come out to be, that is 9 into 10 raised power 9. Then we say Newton meter square upon Coulomb square. So this is the charge between, this is the force between the two charges. So from now onwards, if you have two charges, positive, positive, these two charges repel each other. Okay. With a force that is called electrostatic force, and that electrostatic force is equal to K, Q1, Q2 by R square. Value of K is 1 by 4 pi epsilon naught. This is the value of epsilon naught. This is the value of K. As simple as that. Now, guys, let's talk about this one. Listen to me very carefully. Guys, I want you to understand this very carefully. Let's suppose you have got a box over here. This is the box. Okay. On this box, there is a force acting from this side. There is a force acting from this side. Both the forces are equal and opposite. Means what is the value of theta over here? That is 180 degree. Whenever the angle between the two forces is 180 degree, always remember these two forces cancel each other and net force will come out to be 0. If the angle between the two forces is 180 degree and the two forces are equal and opposite, then in that particular case, we say net force in that case is 0. Okay. Guys, smash the like button. Keep that thing in your mind. Okay. And one more important thing. I would want you guys to join my Telegram channel. That is T dot ME slash YAWAR MANZOOR. This is my Telegram channel. All the notes I share here only. So please do join this, okay? This is very much mandatory. Every notification, every update I put up here only. Okay, so do join this Telegram channel. Okay. Now guys, if you, let's suppose, have a box over here. On this box, one force is acting something like this, another force is acting something like this, okay? Here, angle between the two forces is 0 degrees. Angle between the two forces is 0 degrees. Whenever you have angle between the two forces are 0 degrees, always remember net force will be 2 times of F, okay? Net force will be 2 times of F. This F plus this F will be 2 times of F. Now, directly remember, if the angle between the two forces is 90 degrees, if the angle between the two forces is 90 degrees, this angle over here is 90 degrees. This is F, this is F. Resultant in that particular case is going to be root 2 of F. If this is F, angle between the two forces is 60 degrees. A resultant in that case will be a root 3 of F directly. If 180 degrees, resultant is 0. If 0 degrees, resultant will be 2F, okay? Then. If you have 90 degrees, resultant will be, we say, root 2 of F. If you have two forces and angle between the two forces 60 degrees, resultant will be root 3 of F. And if you have one force F, another force F, angle between the two forces 120 degrees, resultant in that case will be also F. This is what you guys are supposed to remember directly over here. Now guys, let's take a look at the question over here. See, you have got a square over here and there is a force which is present exactly at the center. Okay. Now, before this, I just want to show you this one. That is, take a look. Guys, always remember, if this is a square, okay. Let's suppose this is a triangle. Okay. And what else I can make over here? Okay. Let me make it over here. Then you have got a hexagon. Even if you have got a pentagon, five-sided figure pentagon. Okay. Now guys, if I say charge on this is Q, on this corner is Q, on this corner is Q, on this corner is Q. Means charge on all the corners is identical. And if you place a charge at the center, let's suppose plus Q minus, whatever the charge is at center, net force on the center charge is always 0. Remember it. What is the condition? Charge must be present on every single corner. And. We say charges must be identical. See how? This positive charge will repel this positive charge with the force F. This positive charge will repel this positive charge with the force F. These two will cancel. This positive charge will repel this positive charge with the force F. This positive charge will repel this positive charge with the force F. So net will come out to be 0. Similarly here, if a charge is present, and there is a charge at the center, we say here also net force on the center charge is 0. Now I will not prove it. Directly I want you guys to remember because we don't have that much of time. If I say on this is plus Q, on this is, let me take over here. Let's suppose this is minus Q, 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 this is minus Q. On the center charge, if I am taking plus Q, we say net force on the center charge here also will be 0. Why? Because if identical charges are present at every single corner, then net force on the center charge is 0. Let's suppose here it is minus Q, 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 here it is minus Q. Okay, if you place a charge at the center that is plus Q, here also net force will be 0. Directly I want you to remember. Now, take a look at this question. On this square, you have got plus Q, minus Q, minus Q. Guys, when it comes to the center charge, listen to me very carefully. When it comes to the center charge, here charges are not identical. So net force on the center charge will not be 0. This negative charge will attract it towards itself with a force F. This negative charge will attract it towards itself with a force F. This positive charge will repel it with a force F. This positive charge will repel it with a force F. Now guys, this angle over here is 90 degrees. See. This F and F, I'll make it over here. This is going to be 2F. This F and F, this is going to be 2F. Okay. and angle is 90 degrees. Now you tell me, if the angle between the two forces is 90 degrees, if the angle between two forces is 90 degrees, F, resultant will be root 2f. If this is x, resultant will be root 2x. Now, can I say here, if this is 2f, this is 2f, in this particular case, resultant is going to be root 2 of 2f. Okay, that is going to be 2 root 2f. I hope this is crystal and clear. I hope this is crystal and clear. Okay, I hope this is crystal and clear. Now, guys, when it comes to this diagram, what is going to be, guys, what is going to be net force on the center charge? You have Q, 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 Q. Here charge is not present. So here also you have got Q. Tell me, guys, this Q will repel this Q with a force F. This Q will also repel this with a force F. So these two will cancel. This Q is going to repel it with a force F. This Q is going to repel it with a force F. So these two will also cancel. Now this Q will also repel it with a force F. So only resultant force in this particular case will come out to be F. And if you find this F, this is the force between this charge and this charge. You can write it, this is K, Q1 is Q, Q2 is Q, K, Q square divided by, this distance is 2A. So I would say 2A whole square, K, Q1, Q2 by R square. Is this clear? Please let me in the chats. Please let me know in the chats. Okay, guys, let me know in the chats. Is this clear? Is this clear? How angle is 90 degrees? Because in case of a square, this angle over here is 90 degrees. Okay. Total is 90, 90, 180, 180, 90, 90. Total is 360. Let's move on to this one, guys. Let's move on to the next question. Why are you saying no? This is simple. Why are you saying, guys, no? It's simple, bro. This charge is repelling this charge with a force F. This charge is repelling this charge with a force F. These two forces are equal and opposite, they cancel. This charge is repelling this charge with a force F. This charge is repelling this charge with a force F. These two will also cancel each other. Now, this charge is repelling this charge with a force F. Only this force remains. Rest of the forces are cancelling out. So here net force is equal to this F. Now, this is the force between this charge Q and this charge Q. Distance between these two charges 2A. Now, how do we find the force? F is equal to K. Q1 is Q, Q2 is Q. Q into Q is Q square. Divided by R square. R is 2A whole square. Next, take a look here. You have got minus 2 Coulomb charge, plus 2 Coulomb charge, minus 2 Coulomb charge, 4 Coulomb charge. You guys are supposed to find the net force at this charge, which is 2 Coulomb. See, guys. First of all, this negative charge is going to attract this positive charge towards itself with a force F1. Let me write this force over F1 over here. F1 will be K Q1 Q2 divided by R square. As simple as that. Even I can write it like this, K. K is K. What is the value of Q1? That is 2. What is the value of Q2? That is also 2. So it is going to be 2 into 2 divided by R square. How much is this side? 2 meters. So this distance between these two will be also 2 meters. So it is going to be 2 square. 2 2s are 4, 2 2s are 4. So F1 will come out to be K. Now, guys, we have to find the force on this charge. Now, this minus 2 Coulomb is attract this plus 2 Coulomb. That is going to be F2. That will be K Q1. K Q1 is 2, Q2 is also 2 divided by R square. Distance between these two is R square, that is 2 square. Now guys, this 2 square is 4, 2 square is 4. This will come out to be also K. Now guys, see. This one, this 4 coulomb is repelling this plus 2 coulomb with this force, that is F3. So let me write this F3 over here. Now guys, F3 is K. Q1 is this charge, that is 2. Q2 is this charge, that is 4 divided by R square. Guys, if side is 2, we say diagonal is always 2 root 2. So this will be 2 root 2 whole square. Now guys, see. You can say 2 into 4 is 8. So this is 8K upon. Now 2 square is 4. Square and root will cancel. 4 into 2 is 8. This will be also 8. This and this is cancelled. So answer is K. Now you have got F1, F2, F3. This is the direction of F1. This is the direction of F2. This is the direction of F3. I'll make it over here. This is F1 and value of F1 is K. Okay. And this is F2. Value of F2 is also K. And this one is F3. Value of F3 is also K. Now tell me, what is the resultant of this one and this one? These two forces are at 90 degrees. When the two forces are at 90 degrees, we say resultant in that case will be root 2 of K. If this is F, this is F, this will be resultant will be root 2F. If this is K, resultant will be root 2K. Now guys, you have got from this side it is K, from this side it is root 2 of K. What is the resultant between these two? You say, sir, resultant will be bigger vector minus smaller vector. Here, net force in this case is going to be root 2K minus K. Now here, K you can take out and this is going to be root 2 minus 1. So root K times of root 2 minus 1 is the final answer. Is this clear? Guys, tell me in the chats, is this crystalline clear? Is this crystalline clear? Let me know in the chats if this is crystalline clear, guys. And smash the like button if you have not liked the session yet. Now take a look at this. 3-point charges plus Q and minus Q are placed at the corners of an equilateral triangle. You have got an equilateral triangle over here. Okay. 3 charges. We say plus Q. You have got plus Q and you have got minus Q are placed at the corners of equilateral triangle. Of side A, this side is given as A. And another charge plus Q is placed at the centroid. This is placed at the centroid. Force on plus Q will be, we are supposed to find force on this plus Q. See guys, this plus Q will repel this plus Q with a force F. Okay. Now this plus Q will also repel this plus Q with a force F. This minus Q will attract this plus Q with a force F. Now guys, so on this center charge, I can say one force is in this direction, this is F. Another force is in this direction, this is F. Another force is in this direction, this is F. Guys, always remember, this angle is 120 degrees. This angle is 120 degrees. Okay. Whenever you have two forces and angle between the two forces is 120 degrees, so means the resultant of these two forces will be also F. Because we have studied previously. If you have got the two forces, okay, and angle between the two forces F, resultant in that case will be also F. Resultant will be also F. Okay, yes. Now guys, take a look. Now if this is F and this is F, can I say F plus F? This is going to be 2F. 2F is the final answer. Now see, if you have to properly write the value of F, see, I'll make you understand. Here it is plus Q. Guys, if the side is A, always remember this distance is A divided by root 3. This distance is also A divided by root 3. This distance will be also A divided by root 3. Directly remember. Now, if you have to write the charge force between these two charges, that will be F is equal to K. Q1 is Q Q2 is minus Q divided by R square. R is A by root 3 whole square. So that's what I'm going to write in this particular case. So when I say net force in this case, that will be 2 times of K, Q1, Q2, take this Q and this small q, capital Q, small q, capital Q, small q, capital Q. That is small q, capital Q, divided by distance here also same, here also same, here also same. So it is going R square, that is A square divided by root 3 whole square, that is going to be A by 3. Now 3 into 2, it is going to be 6KQQ divided by A square. This is the answer to the question. This is the answer to the question. This is the answer to the question. Let's take a look at this. Let's take a look at this. See guys, this is the equilibrium position. This is the equilibrium position. Now what does equilibrium position say? If you have a charge over here plus Q, if you have another charge over here n times of Q, if this is Q, this can be 4Q. In that case, n is 4. Okay. And distance between the two charges is, we say, R. Now, my dear friends, I'm saying, where should we place the third charge so that net force on it is 0? Guys, let's suppose if you place the third charge here, this will repel it. That will also repel. We say both are in the same direction, net force cannot be equal to 0. But if you place it over here, guys, if you place it over here, see, this plus Q will repel this Q naught. This n times of Q will also repel this. So these two forces will cancel each other. Net force will be 0. So where should we place the third charge so that net force on it is 0? So you have to place the third charge here. And at what distance? At x distance. This distance is x, at x distance. And if somebody says, sir, what is the value of this x? Directly remember, value of this x is r upon under root of n plus 1. That's it. Let me show you the question. Let me show you the question. Yeah, here is the question. Here is the question. Take a look, guys. You have got 25Q and 36Q. You have to say, where should we place the third charge so that net force on it is 0? This should be the distance. That is x. And if you ask me what is the value of this x, this is going to be r upon under root of n, okay, under root of n plus 1, r upon under root of n plus 1, okay, like you have this one, under root of n plus 1, okay. See guys, so I can say x is going to be r. What is the value of r? R is given as 11 upon root n. How do you calculate the root n? Guys, always remember always remember n is going to be bigger charge divided by smaller charge. That is 36Q divided by 25Q. Q and Q will cancel. This will be 36 divided by 25. Now put it over here. So this is going to be 36 divided by 25 plus 1. Now this will be 11 upon. Root 36 is 6 divided by 5 plus 1. So it is going to be 11 upon 5 into 1 is 5. 6 plus 1 is 6 plus 5 is 11 divided by 5. So you guys will say that is 55 divided by 11. So this will come out to be that is 5 meters. So you have to place it at 5 meters from the smaller charge. Net force on it will be 0. Net force on it will be 0. Now guys, see. If one charge is positive, another charge is negative, plus Q minus n times of Q. In this case, if somebody asks you, where should we place the third charge so that net force on it is 0? So you have to place it from the outer side, and at what distance? At x distance. But when the charges are similar, okay, this of same nature, positive, then you have to place it from the inner side. When the charges are of opposite nature, you have to place it from the outer side. And right now, value of x is r upon under root of n minus 1. If the charges are of opposite nature, then root n minus 1. If the charges are of positive, same nature, then root n plus 1. Okay, yes. Now guys, one more important thing I want to say over here. What is that? That is, what should be the value of Q naught? What should be the value of this third charge Q naught? So that all the three charges are in equilibrium. Guys, till now, I was asking you to tell me the distance. At what distance I need to place the third charge? Here also, I was asking you the distance. At what distance I need to place the third charge. But right now, I am asking you, what is the value of the third charge? What is the value of the third charge? Okay, value of this third charge. Magnitude. You say, sir, it is minus n times of q upon under root of n plus 1 whole square. Let me show you the question, previous year question on this. See, here this is q, this is q. You have to find the value of this q. Third charge. Value of q will be minus n times of q under root of n plus 1 whole square. Now see, minus n. N will be this charge divided by this charge. Q by q is 1, so it will be 1. And n times of q, keep q as it is because charge is q only, divided by root n plus 1. So it is going to be root 1 plus 1, okay, whole square. So now this will be minus q divided by root 1 is 1, 1 plus 1 is 2, 2 square is 4, minus q by 4. Answer in this case is minus q by 4. So basically, if you have to find the value of third charge, this is going to be the formula in that case which you need to use. This is going to be the formula in that case which you need to use. Please tell me in the chats, is this crystalline clear? Is this crystalline clear? Let me know in the chats, guys. Is this crystalline clear till over here? With the fire emojis, with the fire emojis. With the fire emojis. That's great. That's great. That's perfect. Now, guys, equilibrium of two suspended charges. Equilibrium of two suspended charges. Okay. Suspended charges means, let's suppose if you have over here this ceiling, you are attaching over here a charge q and you are attaching one more charge q. Initially, the two charges were close to each other. Now, because of the repulsion, they will basically go far away from each other. Now, at some distance x, these two charges will stop and they remain in the equilibrium. Okay. Yes. Now, guys, if the charges are in the equilibrium, listen to me very carefully. You have to find the value of theta, angle with the vertical. You have to find the value of charge itself. You have to find the value of x. You have to find the tension in the string. Okay. In order to solve this problem, I'll show you one. See, all of these problems have been asked previously in JEE Mains. I'll show you one trick. That is, if this charge is in the equilibrium, draw all the forces acting on the charge. What is the force acting in the downward direction? That is mg. Now, this charge is repelling this charge with what force? Electrostatic force. That electrostatic force will be K q1, q2. Q into q is q square divided by x square. Distance between these two is x. Now, this is tension T. Now, guys, take a look. If this is theta, this is also going to be theta. And this will be T cos of theta. Okay. And here, this is going to be, that is T sine of theta. This is going to be T sine of theta. Okay. Now, guys, I want you to understand one thing. This is T cos theta. This is mg. This is T sine theta. This is electrostatic force. If the charge is in equilibrium, we say charge is in equilibrium. Charge is in equilibrium. What does that mean? Upward force is equal to downward force. This force is equal to this force. So I can say T sine theta will come out to be, that is kq square divided by x square. And T cos theta will come out to be, that is m into g. These are the two equations. Now divide the two equations. T will cancel. Sine theta by cos theta is tan theta. So tan theta will come out to be, that is kq square divided by x square mg. So you got the value of theta. You got the value of theta exactly over here. You got the value of theta, this theta. Theta is equal to tan inverse of this. Now guys, if you have to find the charge q, take this only. So we say, since I'm saying tan theta is equal to kq square upon x square mg, you have to find the value of q. Take it over here. So I can write kq square will come out to be x square mg, then we say tan theta. Now you have to find the value of q. So q square will be, take this down, so x square mg, then we say tan theta divided by this k. Now instead of this square, I can put the root over here. This will be the value of q in this particular case. Even from this equation only, you can find the value of x also. Guys, we say tan theta will come out to be, that is kq square divided by x square into mg. Do one thing, take this x square over here, take tan theta over here. X square will come out to be kq square upon, then we say tan theta into mg. Now you have to find the value of x. So x will be x is going to be, we say under root of, that is kq square upon mg tan of theta. So this is how you can find q. So basically, if you are supposed to find q, x will be given. If you are supposed to find x, then q will be given. Now, the last one, that is T, tension in the string. See guys. In order to find the tension, take a look here. This is the charge q. Okay, this is the charge q. We say on this side, this is the electrostatic force. On this side, this is mg. This is electrostatic force. This is mg. Now, what I want you to understand in this case is, this is going to be the tension. Okay, this is the tension. Then tension was resolved in two components. Guys, see. What is the resultant of this force and this force? Always remember, if you have two forces at 90 degrees, how do we find the resultant? Guys, two forces. Let's suppose we say net force in that case is, if you have two forces, F1 square plus F2 square plus 2 times of F1, F2 cos of theta. This is the formula by which we can find the resultant force. And if angle between the two forces 90 degree, then this term will become 0 because cos 90 is 0. So in that case, it will be F1 square plus F2 square under root. Now see, this and this are at a 90 degree angle. So resultant in that particular case, R will come out to be a root of this Fe square plus we say mg whole square. Yes. Now, since the charge is in the equilibrium, upward force will be equal to downward force. Right side force will be equal to the left side force. This tension force will be equal to this force. So we can say tension will be equals to R. That is going to be, that is Fe square plus mg whole square. This will be the tension in this particular case. And unfortunately, this was asked in JEE mains. We say 2021. This was also asked in JEE mains. We say 2021 in another attempt. Is this clear? Is this clear? Is this clear? Tell me, guys. Okay. Now, guys, take a look. Let's talk about the concept that is relative permittivity. That's relative permittivity. See, guys. Let's suppose you have got two charges, okay? Two charges. The two charges are placed in air. The two charges are placed in air. Okay? Charge is Q1 and this is Q2 and distance is R. When the two charges are placed in air, if I say what is the force between the two charges, you say, sir, force in air is F naught. That is K. What is the value of K? That is 1 by 4 pi epsilon naught. Okay. Then K, then we say Q1, Q2 divided by R square. Okay. This is first equation. Okay. Now guys, listen to me very carefully. And if the two charges are placed in, let's suppose, any other medium, this is Q1 and this is Q2, the two charges are placed in any other medium. Sure. If I say what is the force between the two charges, you say 1 by 4 pi epsilon of that medium. So basically, if medium changes, this epsilon changes. So for free space, it is epsilon naught. For that medium, it will be epsilon of that medium. Then we say Q1, Q2 divided by R square. Now, if I say FO divided by FM, guys, divide this and this. So FO divided by FM, this will come out to be this 1 by 4 pi will cancel. So Q1, Q2 by R square, Q1, Q2 by R square will cancel. So here, what remains? 1 divided by epsilon naught upon 1 divided by epsilon m. Rest of the things will cancel. So this will come out to be, that is epsilon m divided by epsilon naught. Now this epsilon m divided by epsilon naught, this is what we called ER. That is what we called relative permittivity. Now guys, so this FO divided by Fn, force in air between the two charges, upon force in a medium between the two charges, is equal to epsilon R, is equal to relative permittivity. Now what I'm trying to say is that, guys, can I write it like this? From here, take it here. So I can say FO divided by ER will come out to be FM. That is mentioned here. Means force between the two charges in any medium is equal to force between the two charges in air divided by relative permittivity. Okay, divided by relative permittivity. What I'm trying to say is that, I'm saying, let's suppose you have a medium. Okay, this is water. Okay, and relative permittivity of water is 81. ER is 81. If you have two charges Q1, Q2 in this water, okay, placed at R distance. If I say what is the force between the two, you say, sir, force between the two is force in this medium is force in air divided by relative permittivity. You say force in this medium is force in air divided by relative permittivity is how much? That is 81. So means force in this water has been decreased by how many times? 81 times. So relative permittivity gives you an idea how many times force has been decreased in any medium. Let's suppose if you have another medium, okay, medium, it has got relative permittivity 60. What will be the force in this medium? You say force in this medium is going to be, that is force in free space divided by 60 relative permittivity. Means in this medium, force has been decreased by 60 times. So that's what I'm trying to say. Relative permittivity is that concept which helps you to find force in any medium. That's it. And we say this EM divided by E naught is also equal to relative permittivity. Okay. Yes. Now, there was a question which was asked in Neet 2020. What does it say? When air is replaced with a dielectric medium of force constant K. Dielectric medium of force constant K means this is the relative permittivity. Relative permittivity means also it is called dielectric constant also. Dielectric constant. The maximum force of attraction between the charge separated by a distance. It says that initially the two charges were in air, Q1, Q2. Then these two charges are placed in a medium which has got relative permittivity K. Okay, this Q1 and Q2. It says force here will be, force in this medium will be force in air divided by relative permittivity F naught divided by K. So force will be decreased by K times. So when the charges will be placed in that medium, so decreases by K times option A. Yes. So relative permittivity gives you an idea how many times force will be decreased in any medium as compared to the free space, as compared to the air. Okay. Guys, did you smash the like button? I want you guys to smash it as soon as possible. Now, guys, take a look. Let's move on to the next topic. That is what we call the electric field. That is what we call the electric field. What does electric field mean? Let's suppose you have a charge over here, Q. Always remember, a charge creates a field around it. A charge creates a field around it. And if in that field, if any other charge comes, like this Q naught, it experiences force. So this Q naught is in the field of this Q. So it is experiencing the force F. It is experiencing the force F. So if you have a charge, if you bring another charge and you place it in this field, it will experience the force. So it is mentioned, it is the space around a charge. It is the space around a charge in which if any other test charge comes, it experiences the force. It experiences the force. Okay. Now guys, let's suppose you have a positive charge over here. And if you place another charge over here, test charge, this test charge will be repelled in the outward direction. So means direction of electric field for positive charges away from the charge. Always remember this. Direction of positive charge, direction of electric field in case of positive charges away from the charge. And if you have negative charge over here, always remember direction of electric field in case of negative charge is always towards the charge. Always towards the charge. Always towards the charge. Okay. Yes. Now guys, I want you to understand this point. What is that? See. We say electric field due to a point charge. If you have got a charge over here, we know it will create the field around it. How much will be the electric field due to this? What is the magnitude of the electric field due to this? At what distance? At small r distance. Simply, we say electric field due to this is going to be, that is K Q divided by R square. Q is the charge, R is the distance at which you guys are supposed to find the electric field. Now, what is the relation between electric field and R? It is inverse relation. So if you make the graph between E versus R, it will come out to be rectangular hyperbola. It will come out to be rectangular hyperbola. Okay. Now guys, take a look. Here you have got n number of charges. Okay. These charges are till infinity. What I want you guys to understand in this particular case is, this is positive, this is negative, this is positive, this is negative. You have to tell me what is going to be the net force at the origin due to all these, sorry, not net force, net electric field. What will be the net electric field due to all these charges at the origin? Like here. Electric field due to a point charge at r distance, kq by r square. We have to find due to all. Can I say net electric field is going to be electric field due to this charge at origin? This is at 1 meter distance. So this is kq divided by 1 square is 1. Then we say minus. Electric field due to this charge, kq divided by 2 square. What is the distance from here to here? It is 2 square. That is 2 square is 4. Then we say plus. Electric field due to this, which is at 4 meter distance. So I can say this is kq divided by 4 square is 60. Then minus kq divided by, what is this distance? 8. 8 square is 64. Plus so on. Now guys, in this case, we can take kq common. and here it is 1, then minus 1 divided by 4, then plus 1 divided by 16, minus 1 divided by 64, plus so on, plus so on. Okay, yes. Now guys, what I want you to understand in this particular case is, that is, this is what we call GP. You have to add all of these terms, you will get the answer. And there is a formula to add. S is equal to, sum is equal to, we say sum is equal to, we say A upon 1 minus R, A upon 1 minus R. A is the first term, A is the first term, okay, this first term, this is A. And R means the common ratio. How do you calculate the common ratio? We say take any term in this one. Let's suppose I'm taking 1 by 16. Divide it with the term which comes before it. That is minus 1 by 4. 4 ones are, 4 fours are. So common ratio is minus 1 by 4. Okay. Now put it over here. Get the value of sum. If you put it over here, so sum will come out to be A is 1, first term, 1 minus, and common ratio is also minus 1 by 4. So it is minus 1 by 4, minus into minus is plus. So it will be 4 into 1 is 4, 4 plus 1 is 5, 5 by 4. 1 upon 5 by 4. So it will be 4 divided by 5. Okay. Now, instead of all of this, I'll be writing 4 divided by 5. So net electric field will come out to be KQ. Then we say 4 divided by 5. Now tell me guys, what is the value of K? This is 1 by 4 pi epsilon naught. Then we say Q, 4 divided by 5. 4 and 4 will cancel. Final answer will be Q divided by 5 pi epsilon naught. Q divided by 5 pi epsilon naught. So this will be the net electric field due to all these charges at the origin. Take a look. Guys, since you said if you have a charge, it creates the electric field around it. If you have a charge, it creates the electric field around it. Okay? Yes. If you have a charge, it creates the electric field around it. Now, if you place the same charge, on this ring, if you place the same charge on this ring, if you distribute the same charge on this ring. Now, my dear friends, we say this ring will also create the electric field. If you place this charge on this pen will also create the electric field. Whenever you have charge, it will create electric field. Now, the radius of the ring is R. It is a ring, something like this. You have to find the electric field due to this ring at x distance. Directly remember, electric field due to ring at x distance, it is going to be K, Q, X. K is the K, Q is the charge on the ring, okay? X is the distance at which you have to find the electric field, divided by, we say R square plus X square. R is the radius and X is the distance, R square plus X square. Whole raised power 3 divided by 2. Whole raised power 3 divided by 2. This is the electric field due to a ring on its axis at x distance. Now, if I say what is the electric field at the center? Can I say at center value of x is 0? But why? Because you are measuring the x from the center only. If you move towards the center, you are decreasing x. And at center, x is 0. If you put x is equal to 0, this whole term will become 0. Electric field at the center is 0. Electric field at the center is 0. Now guys, listen to me very carefully. If I say graph between electric field versus R, so this graph is going to be something like this. This graph is going to be something like this. Okay? And this is the graph of electric field versus R in case of the ring. And remember guys, this electric field will be maximum at x is equal to plus R by root 2, where R is the radius of the ring, and x is equal to minus R by root 2. Because from the left side also, if this is a ring, it creates the field from this side also, from this side also. That's why graph is from both the sides. Okay. Now take a look at this one. Electric field due to a segment of ring. What does segment of ring mean? Guys, this is a complete ring. Okay, this is a complete ring. If I say, sir, how much is this? This is called the semicircular ring. This is called the semicircular ring. Okay, yes. If I say, sir, How much is this? This is called chord. This is called chord. Okay. If I say from here till here, this is called some part of the ring. Or we say this is the segment of the ring. We say this is the segment of the ring. We say this is the segment of the ring. We say this is the segment of the ring. Now, if you are taking this segment of the ring, we say this is the charge Q distributed here. Now, if you join, this is the center, join this center with one end of the ring, this is the radius R. Join this center with another end of the ring, this is the radius R. Now, guys, angle between this radius and this radius is theta. If I say how much is the electric field due to this at this center, you'll be saying E is equal to 2k lambda by R, 2k lambda by R, okay? Then we say sine of theta by 2. 2k lambda by R, then we say sine of theta by 2. 2k lambda by R, then we say sine of theta by 2. 2k lambda by R, then we say sine of theta by 2. Okay? Now guys, this is the general formula. Let's suppose if we are taking a semicircle. In case of a semicircle, this is the radius R, this is also radius R. Angle between these two is 180 degrees. Now, what is the general formula? E is equal to 2k lambda by R. Then we say sine of theta by 2. Theta is 180 divided by 2. Or if you say theta is pi, 180, whatever you say. So, E is 2k lambda by R. Sine of 180 by 2, sine 90 is 1. So, this will be electric field due to this. Okay. And when it comes to the chord, in case of a chord, we say theta is 90. Electric field will come out to be 2k lambda by R. Then we say sine of 90 by 2, that is sine of 45. Sine of theta by 2, sine 45. Now I can write it like this, E is equal to, that is 2k lambda by R. Sine 45 is 1 by root 2. Now do one thing, multiply with root 2 and divide with root 2. Now root 2 into root 2 is 2. That 2 will cancel with this 2. Now what remains over here? E is equal to, that is root 2 k lambda divided by R. This is the electric field due to a chord. This is the electric field due to a chord. Now let's solve some questions on this. Take a look. This is a circle, okay? And when it comes to this circle, if you check over here, we say this chord contains positive charge, this negative, negative, negative. You guys are supposed to say in this particular case, what is going to be the net electric field at the center? Guys, see? So you have divided this circle in 4 parts. This chord will have the electric field away from the charge over here, okay? Sir, why away from the charge? Because in case of when it comes to the positive charge, electric field is away from the charge, okay? Okay. And because of this chord, this will be root 2k lambda by R. Radius is R. Now, electric field, this portion of the chord will be towards this, okay? Root 2k lambda by R. Why? Because it is negative charge. Electric field due to this negative, it is root 2k lambda by R. Now. The last one. Electric field due to this chord, it will be also root 2k lambda by R. Now, this will cancel with this one. These two will add. So, can I say net electric field will be this plus this? It is in the same direction. So, 2 times of root 2k lambda divided by R. This will be the net electric field at the center. Is this clear, guys? Tell me in the chats. Is this clear? Tell me in the chats. Guys, smash the like button if you have not liked the session yet. Okay. Now, guys, let's suppose you have a question like this. Okay. This is a circle, and in this circle, upper portion has got positive charge, lower portion has got negative charge. Okay. Divide this in two parts. This is a semicircular ring. Because of this positively charged semicircular ring, electric field is away from the charge. Okay. And it will be 2k lambda divided by r. Electric field due to this negatively charged portion, it will be also towards the ring. So this will be also 2k lambda divided by r. Now, if you have got two vectors in the same direction, can I say net is going to be 2 plus 2 is 4k lambda divided by r. 4k lambda by r. 2 plus 2 is 4k lambda by r. Okay, what about this? Guys, this portion has got positive charge. This chord has got negative charge. You are supposed to tell me what is the electric field at this point. Due to this positively charged chord, electric field will be away from the chord. Root 2k lambda by r. Due to this negatively charged chord, electric field will be towards the chord. Root 2k lambda by r. Angle between these two is 90 degrees. Always remember, here angle is 90. Now tell me, if angle between the two vectors is 90, what is going to be resultant in that case? Can I say this resultant will be, guys, if this is x, resultant will be root 2x. If this is f, resultant will be root 2f. If this is root 2k lambda by r, resultant is going to be root 2 of, we say, root 2k lambda by r. Now, root 2 into root 2 is 2k lambda divided by r. I hope this is also clear. I hope this is also clear. Now, guys, find the charge. Okay, finite charged rod. Since I told you, if there is a charge, there is electric field. If you distribute that charge on a sphere, it will create electric field. If you distribute that charge on a rod, it will create electric field. Okay. Now, here I am distributing the charge on this rod. Okay, I am distributing the charge on this rod. Okay, I am distributing the charge on this rod. Now, my dear friends, what I am trying to say in this particular cases, that is, see, you have to go at r distance from the rod. Join this point with one end of the rod and this will be angle theta 1. Join this point with another end of the rod, this is going to be the theta 2. Okay. Now, due to this rod, what will be the electric field at this point? What will be the electric field at this point? Directly remember, E is equal to k lambda divided by r, then we say sine of theta 1, this angle. Then we say plus sine of theta 2, okay, this angle, sine of theta 2. Then we say plus cos of theta 1, okay, cos of theta 1 minus cos of theta 2. This is going to be the electric field. Okay, due to a finite rod at r distance, Okay. What is this lambda? Lambda is charge per unit length. Okay, charge per unit length. Okay, lambda is equal to q divided by or dq by dl, charge per unit length. Okay, finite charged rod. Now, guys, if you exactly take this point, exactly over here at the center, okay, this is our distance. Now, don't you think if you are taking this at the center, this theta 1 will be equals to theta 2? Theta 1 will be equals to theta 2. Yes. If theta 1 will be equals to theta 2, guys, use this equation. If theta 1 is equal to theta 2, what is going to be the electric field? That is k lambda divided by r. Then we say sine of, and consider it theta, sine of theta plus I say sine of theta. Okay. Then we say plus cos of theta minus we say cos of theta. I can say it like this. Cos theta minus cos theta is 0. Now sine theta plus sine theta is 2 sine theta. So this will come out to be 2 times of K lambda divided by R, then I say sine of theta. This will be the electric field in that case. So that is here, that is 2K, that is 2K lambda by R sine of theta, 2K lambda by R sine of, okay, if you have taken exactly the point, and this is called equatorial point or equatorial position, okay. Now, if you consider the rod which is infinitely long, this is still infinity, okay. Now guys, this is the R distance. If you have to make the angle 1 over here, will you make it like this, angle theta 1? Okay, no. You have to join this with this rod which is with the end of the rod which is at infinity. So means you have to go like this. So in this case, theta 1 will be 90. In this case, we say theta 2 will be 90. So in case of the infinitely long rod, theta is 90. Okay. Now tell me guys, if theta is 90, theta 1 is equal to theta 2 is equal to 90. Okay. Now you can say 2K lambda by R sine of 90. Sine 90 is 1. In that case, it will come out to be 2K lambda by R. So electric field due to an infinitely long rod, it is 2K lambda by R. Okay. Okay. 2K lambda by R. Okay. Now guys, listen to me very carefully. Let's suppose you have a semi-infinite rod. Means one end of the rod is going till infinity. One end of the rod is going till infinity. Another end is over here, finite. At this point, you have to find the electric field, okay? So this will be, directly remember, okay? I'll not derive it. Directly remember, this will be the electric field due to a semi-infinite rod at R distance, okay? In case of semi-infinite, we say theta 1 is 0 degrees and theta 2 is 90 degrees because another end is at infinity. Directly remember. And in case of this, both the angles are 90. Let's take a look at this question. This was asked in Neet 2019. You have got two infinitely long rods, okay? On this rod, charge is positive. On this rod, charge is negative. You have to tell me at R distance, what is the electric field due to both? Guys. Electric field due to negatively charged rod, it will be towards the rod. And due to infinitely long rod, it is 2K lambda by R. Electric field due to positively charged rod, it will be 2K lambda by R. When it comes to the net electric field, it is going to be 2K lambda by R plus 2K lambda by R. So this will be 4K lambda divided by R. This will be the net electric field. This will be the net electric field. That is 4K lambda by R. That is 4K lambda by R. Okay. Is this clear, guys? Is this clear? Okay, is this clear? Now, guys, see, there is a question over here. You have got an infinitely long wire. At R distance, you have an electron or a negative charge, which is having the minus Q charge, mass M. Now, you are giving some velocity to it. This is a wire. This is a charge. You are giving some velocity to it. Now, it will start rotating. Okay, it will start revolving around the wire. It will start revolving around the wire. Okay, it is not. Okay, it will start revolving around the wire. Now, my dear friends, we say it is at r distance. It is at r distance. Okay, it is at r distance. Now, if I say this point over here, this point over here, this charge over here, you have to tell me what is the value of this velocity. How much velocity should we give it so that it performs the complete circular motion? How much velocity should we give it so that it performs the complete circular motion? So that it performs the complete circular motion. Okay, yes. Now take a look. Can I say in this particular case, guys, two forces will act. Whenever the particle moves in a circular motion, we say centripetal force will act is equal to, and here, we say a charge is in the electric field of this wire. See, take a look. One important thing. Let's suppose you have got an electric field over here. This is the electric field. In this electric field, if you place a charge, always remember, if you place a charge in the electric field, force acts on this charge. That is Q times of E. Q times of E. Now, here, electric field due to the wire is E. And in this electric field, there is a charge Q. Now, we say force will act on it. That is electrostatic force. This centripetal force will be equals to mv square divided by r is equal to electrostatic force here will be, that is Q times of E. Q times of E. Okay. Now, guys, take a look. I can write it mv square divided by r is equal to Q times of E. E is the electric field due to wire. That is 2k lambda divided by r. R and r will cancel. You have to find the value of V. Take this over here. V square will be 2k lambda and then we say Q divided by M. V will be equals to under root of 2k lambda Q divided by M. This will be the velocity of the charge with which it is revolving. This is the velocity of the charge with which it is revolving. Okay? Okay? So this is the velocity of the charge with which it is revolving. Now, guys, take a look. Let's move on to the next topic. That is what we call the electric flux. That is what we call the electric flux and Gauss law. What is electric flux? Electric flux is simply the number of electric field lines crossing the surface perpendicularly. Like this is the surface over here. Okay, like I have a sheet over here. Now there is a charge. Due to this charge, electric field lines are coming out. Electric field lines are coming out of the charge. Okay. And these electric field lines are crossing this surface. These electric field lines are crossing this surface. So you have got a surface over here. Okay, you have got a surface over here. Okay. And we say you have the charge over here. Due to the charge, electric field lines are coming out and these are crossing the surface perpendicularly. When these lines are crossing the surface perpendicularly, we say how many lines? 1, 2, 3. Flux is being created. How much is the flux? 3. Now see, more is the electric field, more will be flux. More is the area of this sheet, more will be flux. So we say flux is directly proportional to electric field, flux is directly proportional to area. So if you combine the two, you can say flux is equal to E into A and cos of theta, EA cos theta. So you can say flux is equal to E dot A, because A dot B is equal to AB cos theta. EA cos theta will be E dot A. As simple as that. What is important in this one? That is Gauss law. What is important in this one? That is Gauss law. Gauss law is, what does Gauss law say? It says the number it says that flux through any closed surface is equal to charge inside divided by epsilon naught. Take a look, guys. Take a look, guys. I want you to understand. Let's suppose this is a cylindrical surface over here. This is a cylinder. Okay. Inside the cylinder, you have got this charge. Inside the cylinder, you have got this charge. We know because of the charge, field lines are coming out. Field lines are coming out of the charge. Because of the charge, field lines are coming out. These are the field lines which are coming out of the charge. Okay. Now, these field lines are crossing the surface, so flux is being produced. Gauss said you don't have to calculate the flux over here. Directly remember, flux will be whatever is the charge inside, that is Q divided by epsilon. If I say here it is 10Q, you'll say, sir, flux through this surface will be 10Q divided by epsilon. Okay. Okay. So this surface must be the closed surface. That is the condition. Like here, what is the flux through this surface? Q divided by epsilon naught. Here, take a look. You have this hemispherical bowl, and charge is placed at the mouth. Charge is placed at the mouth. Okay. Charge is placed at the mouth of the hemispherical bowl. You have to find the flux through the bowl. Guys, take a look. Take a look. This is not the enclosed charge. This is not present inside the bowl. It is present at the mouth of the bowl. Okay. Now, guys, if you want to make it a closed surface, you have to join one more hemispherical cup over here. Okay. Imaginary hemispherical bowl over here. Now, these are the two bowls. Now, can I say, now this charge behaves like an enclosed charge which is present at the center of these two bowls. Okay. We say flux through closed surface. Here, closed surface for this charge is made up of two bowls. So that will be flux through two bowls is equal to Q divided by epsilon naught. Okay. Now, I can say in this particular case, this is the flux through two bowls. If I say flux through one bowl, that is going to be, this is the flux through two bowls. Flux through one bowl will be half of this, 1 by 2 Q divided by epsilon naught. Half of this. Okay, half of this. Okay. Let's say this one. What about this one? See, if the charge was present inside, then I would have said, sir, flux will be Q by epsilon naught. But charge is present at the mouth. What I want you guys to do is, you connect one more imaginary cylinder to it. Okay, now this behaves like a closed surface for this charge. Now tell me, flux through closed surface will be flux through two cylinders, and that will be Q divided by epsilon. That will be Q divided by epsilon. Okay. Now guys, this is flux through two cylinders. Can I say flux through one cylinder? That will be half of this one, 1 by 2 of Q by epsilon naught. That is going to be Q divided by 2 epsilon naught. This will be the flux through two cylinders. I hope this is crystalline clear. Flux through one cylinder. Is this clear? Now guys, if the flux through the curved part is phi naught, then flux through the mouth will be, guys, see. This charge is present inside the hemispherical bowl, okay? It says flux through this curved part, it is phi naught. How much will be the flux through this portion? Guys, see, when it comes to the flux through closed surface, it will be, here closed surface is made up of two surfaces, this plane surface and this curved surface. So that will be flux through plane surface plus flux through curved surface. Because we say field lines will leave, so they will cross the curved surface also, plane surface also. And this is Q divided by epsilon naught. Okay, net flux through closed surface. Now flux through curved surface is given as phi naught. So I can say flux through plane surface plus flux through curved surface, it is phi naught, is equal to Q divided by epsilon naught. So flux through plane surface will come out to be, take this over there, Q divided by epsilon naught minus we say phi naught. Okay, what about this one? This is a cylinder over here. This is a cylinder over here. Okay. And it says that if the flux passing through R, this curved surface, is phi, find the flux through one plane surface. The similar type of question. It is like, guys. We say, if you take a cylinder over here, let's suppose this is a cylinder. This cylinder has got how many faces? We say this is the plane face, this is the plane face, and this is the curved face. So if there is a charge present inside, so flux will be field lines will cross this portion also, this also. Now, it says that flux through this curved part is phi naught. First of all, can I say closed surface, flux through closed surface here will be, is flux through this plane surface, two plane surfaces plus flux through one curved surface. Now, flux through closed surface, that is Q divided by epsilon naught is equal to flux through two plane surfaces. Okay. So that is flux through two plane surfaces plus flux through curved surface, that is given as phi naught. Okay. Now take it over here. So it will be Q divided by epsilon naught minus phi naught will be equals to the flux through two plane surfaces. Now guys, this is the flux through two plane surfaces. If you have to find the flux through one plane surface, that is going to be 1/2 of this much. So that is 1/2 of Q divided by epsilon naught minus phi naught. Q divided by epsilon naught minus phi naught. Now guys, take a look over here. Electric field due to a hollow sphere or a metal conducting sphere. We also call it the conducting sphere. Okay. Guys, see. In this particular case, hollow sphere means which is hollow from inside, like football. So if you store the charge on the hollow sphere, it will be stored on the surface. Now guys, radius of this hollow sphere is capital R. Now guys, listen to me very carefully. You have to tell me the electric field due to this hollow sphere at outside point, which is at small r distance. Outside point. You have to tell me electric field due to this hollow sphere on the surface at capital R distance. On the surface. Okay. You have to tell me electric field inside. First and the foremost thing. When it comes to the outside point, electric field will be kq divided by small r square. Because from a very large distance, we consider it a point charge only. So it will be kq divided by small r square. When it comes to the surface, if you keep on moving towards the surface, this is the surface. At surface, we say value of small r will be equals to the capital R. So this small r will be equals to the capital R. Electric field will be kq divided by capital R square. Kq divided by capital R square. And when it comes to the inside, we say inside, my dear friends, charge is 0. There is no charge present inside. So electric field inside will be 0. Inside charge is 0. So electric field inside is going to be 0. Electric field inside is going to be 0. Okay. Now take a look. Now take a look. Now take a look. Guys. Graph between electric field versus X in case of a hollow sphere. Tell me one thing. Electric field inside is 0 because there is no charge present inside. Electric field outside is inversely proportional to R square. Electric field on the surface is kq divided by R square. Q is constant, K is constant, capital R, radius is constant. Now see, if we make the graph between E versus small r, listen to me very carefully. Listen to me very carefully. This is the hollow sphere. Can I say inside electric field is 0, so on this line? And outside, I can say electric field is inversely proportional to small r square. This is outside. Okay. And this will be the surface. This will be the surface. Outside it is inversely proportional to r square. Now see guys, here. Electric field due to a solid non-conducting sphere. Solid non-conducting sphere. Electric field due to a solid non-conducting sphere. I see. This is the sphere over here we have got. This is the sphere. Okay. When it comes to a solid non-conducting sphere, this is the positive charge present inside the sphere. Non-conducting solid sphere means in which charge is present inside also. Hollow sphere means in which charge is present on its surface only. Your charge is present inside also. Now guys, what I'm trying to say in this particular case is, when it comes to the solid non-conducting, you have to find the electric field outside at smaller distance. You have to feel on the surface, you have to feel inside. When it comes to the outside, it will be kq by small r square. Small r is the distance outside. When it comes to the surface, r is equal to capital R, so it will be kq by capital R square. When it comes to inside, electric field is going to be kq into r divided by r cube, where capital R is the radius. Guys, electric field outside is inversely proportional to small r square. Electric field inside is directly proportional to small r. Keep these things in your mind. Now take a look. If you have to make the graph between E versus R, so graph between E versus R, it is going to be, guys, this is the center. We say from center to surface, electric field is directly proportional to small r. That's what I say inside. And this is the surface, where at surface r is equal to capital R. And outside the surface, electric field is inversely proportional to small r square. Take a look. This was the question asked in JEE Advanced 2014. See what does the question say. You have got a sphere, you have got another sphere, you have got another sphere. You have to tell me electric field due to this sphere at point P. You have to tell me electric field due to this sphere at point P. Here at point P. Radius of this sphere is these are all solid spheres. Radius of this sphere is r by 2. So you have to find the electric field at capital R. So capital R will be outside. Here radius of this sphere is r. Electric field at r will be on the surface. Radius of this is 2r. Electric field at r will be inside. See, electric field in the first case. Here point is outside, so we'll use the outside formula, that is kq divided by small r square. Now this is k, charge on this is q, and small r means the distance at which you have to find the electric field, that is capital R over here. Then you say electric field on second case, so this is the surface point, so it is kq divided by capital R square, where capital R is the radius. This will be here, what is the charge on this sphere? That is 2q, k into 2q upon capital R square. Then electric field in the third case, this is the inside point. In case of a solid sphere, electric field inside is kq into small r divided by capital R cube. So here you will be writing kq into small r divided by capital R cube. Capital R is the radius, small r is the distance at which you have to find the electric field inside. So it will be k, charge on this is 4q, okay. Small r is this r divided by, then you say this one, that is 2r whole cube. Now this will be k4q or 4kq into r upon 2 cube is 8r cube. This and this will, here it remains r square, so 4 ones are 4 twos are. So this is kq upon 2r square. kq upon 2r square. So this is going to be the electric field at this point. This will be the electric field at this point. This will be the electric field at this point. Okay. I hope this is clear. Now, one more point exactly over here. That is what I'm going to tell. Electric field due to an infinitely large non-conducting sheet or plate. Electric field due to an infinitely long sheet or plate. Okay. Okay. Now guys, electric field due to an infinitely long non-conducting sheet or plate. I want you to understand this. When it comes to the sheet, let's suppose you are having a sheet over here and positive charge is present on the sheet. This is the positive charge which is present on the sheet. This is the positive charge which is present on the sheet. Okay. Now guys, if positive charge is present on the sheet, you have to tell me electric field at point P. You have to tell me electric field at point P. See, we say because of this sheet and this is a non-conducting sheet, electric field is going to be sigma divided by 2 epsilon naught. What is this sigma? Sigma means charge per unit area. Means on the unit area of the sheet, how much charge is present, that is going to tell you, sigma is going to tell you that. Charge per unit area, sigma divided by 2 epsilon naught. Okay. When it comes to a conducting plate looks something like this. It is made up of 2 sheets. In between the 2 sheets, there is no charge. Okay. There is no electric field. Okay. So we say it is, this charge is made up of these, this conducting plate is made up of 2 charged sheets, something like this. And here, electric field is going to be sigma divided by epsilon naught. Okay. Okay. And my dear friends, one more important thing. electric field due to a non-conducting sheet in terms of sigma. In terms of charge, it is going to be Q divided by 2A epsilon naught. And here it will be electric field in terms of charge Q divided by 2A epsilon naught. So in terms of charge, electric field in both the cases will be same. But in terms of sigma, here it is going to be sigma divided by epsilon naught. Here it is going to be sigma by 2 epsilon. But in terms of charge, electric field in both the cases will be same. Now see, two parallel non-conducting sheets. Okay. Two parallel non-conducting sheets. This is one sheet. This is another sheet. This is another sheet. Okay. Now charge on this sheet is positive. Charge on this sheet is negative. Now you guys are supposed to tell me, we have 3 points A, B and C. At which point electric field will come out to be zero, net electric field. See guys, electric field due to this sheet at this point will be away from the sheet. Okay, this is electric field due to positively charged sheet. Electric field due to negatively charged sheet, it will be towards the sheet. So I can say net electric field in this case is zero. Okay, because this will be cancelling with this. Now at point B, electric field due to this sheet will be towards the sheet. Electric field due to positively sheet will be away from the sheet. So here electric field at point B is not equal to zero because both the electric fields are in the same direction. Electric field at point C, due to this sheet, electric field at point C will be towards the sheet. Due to the negatively charged sheet, electric field will be away from the sheet. Okay. So we say here electric field will be again equal to zero at point C. Sir, does electric field depend upon the distance from the sheet? No. These are the infinitely long sheets. There is no term of distance, okay? If there is a big infinitely long big sheet, if there is an infinitely long big sheet, okay, you say if you take the point here, it's one and the same thing. Okay, it's one and the same thing. It is one and the same thing. Okay. Okay. Is this clear, guys? Is this clear, guys? Now, guys, take a look. Take a look. Motion of a charged particle in a uniform electric field. Motion of a charged particle in a uniform electric field. See. Let's suppose you have the electric field over here. This is the electric field that you have got. Okay. Yes. In this electric field, you have placed a charge. That is plus Q. Okay. Yes. Whenever you place a charge which has got mass m in an external electric field, it experiences the force. F is equal to Q times of E. Okay, this is the force F. And if there is a force acting on a body, it will have acceleration. We say acceleration is force divided by mass. What is force? Force is Q times of E. Mass is m, QE divided by m. Okay. Now, if force is acting on this charge, it will cover some displacement. It will move. This is the displacement of the charge. 1 by 2 QE divided by m into t square. After time t, displacement after time t. Q is the charge, E is the electric field, m is the mass of the charge, t is the time t. Now, since the charge is moving, after some time it will gain some velocity. Velocity will be QE divided by m into t. Q is the charge, E is the electric field, M is the mass, T is the time. Next, we say momentum after time t. Guys, momentum will be QET. Q is the charge, E is the electric field, T is the time t. Kinetic energy after time t, Q square, E square, T square. Charge, electric field, time divided by 2m, divided by 2m. Okay. Then, my dear friends, next, velocity after displacement S, x. Let's suppose this charge has moved from this point to this point. After covering displacement x, how much will be the velocity of the charge? This one was after time t, how much is the velocity? This is after displacement x, how much is the velocity? V square is equal to 2qe by m into x. 2qe by m into x. Okay. Okay. Yes. Even you can make the graphs over here also. If somebody wants to plot the graph between, plot the graph between momentum and time, this will be this, momentum versus time, directly proportional. Kinetic energy versus this, it will be this, because kinetic energy is proportional to t square. Kinetic energy and time. Okay. V is proportional to root x. So here it is going to be this. In this particular case, S and T square, displacement and time, this will be the graph. Displacement versus time, because S is proportional to T square, upward parabola. V is proportional to time. In this case, graph will be straight line, V versus time. V versus time. Now guys, take a look. Charged particle projected perpendicular to the electric field. Guys, here. Charged particle was projected parallel to the electric field. Here, charged particle is moving parallel to the electric field. But when it comes to this one, charged particle is projected perpendicular to the electric field. This is the direction of electric field. Okay. Charged particle is entering something like this with a velocity u. Guys, see. This electric field will apply force on this charged particle in the upward direction, and that is q times of E. Charge wants to go in the forward direction, something like this. Due to the force, it will be pulled in the upward direction. If this force was not acting, it would have crossed directly. Something like this. But since the force is acting, it will be dragged. Okay, it will deviate its path, and finally it will come out here with a velocity v. Now this angle over here is theta. This will be v cos theta. This component is going to be vx. This component is going to be vy. This will be vx and this will be vy. Now guys, if I say this is the angle at which the charge is coming out of the electric field. If somebody says what is the value of this angle, directly remember theta is equal to tan inverse of QED. Q is the charge, E is the electric field, D is the distance in which electric field is present. Separation. Okay. Mu square. M is the mass of charge. U is the velocity with which it is entering the electric field. U is the velocity with which it is entering the electric field. Okay. Next. Take a look. Guys, here you have got a question. Electric field is in the upward direction. Okay. In this region. And there is an electron which is released over here. Okay. And how much time electron is going to take in falling down? Okay. In reaching here. Okay. This is what we need to calculate. Now. Here you have reversed the direction of electric field. Electric field direction is downwards. This is the proton. You have placed a proton over here. This is the proton. Now proton will fall. How much time it is going to take in falling? That's what we need to calculate. Guys, see. Both are having the same magnitude of electric field. Okay. And both are covering the same vertical height. You have to compare the time of fall of electron, time of fall of proton. Guys, see. We say S use. We say use S is equal to ut plus 1 by 2 at square. So basically it says you have an electron, you have a proton. You are releasing both of these in the electric field. But here direction of electric field is upward, here direction is downward. So my dear friends, how much time this is going to take in falling? How much time that is going to take in falling? Initial velocity in both the cases is 0 because we are releasing this. So initial velocity in both the cases is 0. We say S is the displacement covered, that is H is equal to 1 by 2. Acceleration in this particular case, that is QE divided by M into T square. Because what is the acceleration of a charge placed in the external electric field? QE divided by M. Okay, now take it over here. 2M into H divided by QE will be equals to T square. So can I say T will be equals to under root of, that is 2M H divided by QE. Now you tell me one thing, guys. When it comes to the time, and we say, guys, see. 2 is constant for both. H is same for both. Both are covering the same vertical height. We say charge on both is same. Nature-wise, it is opposite. This has got negative charge, that has got positive charge. But can I say time is proportional to root of mass? So the one which has got more mass will take more time in falling. Now take a look. We say mass of proton is greater than mass of electron. So can I say time of fall of proton is greater than time of fall of electron? So electron will take less time in falling, proton will take more time in. I hope this is clear. Is that clear, guys? Tell me in the chats. Tell me, guys. Is that clear? Direction of the field is different, yes. And that's why in this particular case, see, one thing is there. What is that? That is. See, if this is the electric field, external electric field, okay? If you place a positive charge in the external electric field, force will be in the same direction of the electric field. If you place the negative charge, force will be in the opposite direction of electric field directly. Now see, here electric field is upward. Magnitude wise electric field is same in both the cases. Then we say force is acting on this charge in the opposite direction because this is a negative charge. Force on this will be opposite to electric field. Here, this is a positive charge. Force on this will be same as the direction of electric field. Okay. Okay. Now. Guys, see. If the proton, deuteron and an alpha particle are placed in the uniform electric field, then find the ratio of the momentum after time t. Guys, see. Proton, alpha particle and deuteron. When it comes to the proton, when it comes to the deuteron, okay, when it comes to the alpha particle, Mass of proton, guys, it is m. For this deuteron, it is 1h2, so it is going to be 2m. And for alpha particle, it is going to be 4m. Okay? Okay? Yes. And guys, we say charge on proton is E, charge on deuteron is E. Okay? Charge on this, it is going to be 2e. This is charge, this is mass. These are the three different particles. It is 1h2. It is 2He4. One proton, one neutron. Two protons, two neutrons, and a proton. Now, if all the three are placed in the external electric field, you have to tell me ratio of their momentum. Guys, tell me. Momentum is Q, E, and T after time T. So, time is same for all the three. Time is constant. Okay? Okay. And when it comes to the electric field, all the three are placed in the same electric field. Okay? So, can I say momentum will be proportional to charge? So, momentum of proton is to momentum of deuteron is to momentum of alpha particle. This will be that is E is to 2E. So, I can say 1 is to 1 is to 2. 1 is to 1 is to 2. Even in the same question, you can find the kinetic energy ratio also. See, after time t, what is the value of kinetic energy? Q square E square T square divided by 2m. Let me show you over here. When it comes to the ratio of kinetic energy of proton is to kinetic energy of deuteron is to kinetic energy of alpha particle. Guys, kinetic energy is Q square E square T square divided by 2m. Now, for all the three, we say time is same. Okay, for all the three, electric field is same. So, kinetic energy will be proportional to Q square divided by m only, because 2 is also constant. Q square by m. Now, charge of proton is E by m. So, I'll write E divided by m is to. Then we say deuteron. For deuteron, it will be E square. Okay, it is Q square by 2m. So, E square divided by m. So, now it will be E square divided by 2m. Then we say is to. For this, it will be 2e square, that is 4. 2 square is 4. 4e square divided by 4m. Okay? Okay? This is going to be the ratio in this particular case. This is going to be the ratio in this particular case. Okay? Now, you can do the simplification also. E you can cancel. M you can cancel. So, 1 is to 1 by 2 is to, you can say 1. Okay? So, further you can simplify from your end. Now, but sir, it is 2m. For alpha particle, it is 4m. For deuteron, it is 2m. Okay? Array, for 2 is constant. I am saying proportionality here. What is constant in this equation? Sir, for all the three electric field is constant. Time is constant. 2 is constant. So, kinetic energy will only depend upon Q square divided by m. Proportionality I am using. Electric dipole. Electric dipole. Electric dipole. Guys, take a look. When it comes to the electric dipole, we say when two equal and opposite charges are placed at a very small distance, are placed at a very small distance, it forms electric dipole. It forms electric dipole. Okay. When two equal and opposite charges are placed at a very small distance, it forms electric dipole. It forms electric dipole. Now, guys, you have a negative charge over here, minus Q. You have a positive charge over here, plus Q. Okay. And separation between the two charges is D. Separation between the two charges is D. And my dear friends, in this particular case, this is what we call the dipole. Equal and opposite charge separation by some distance. And this dipole also has a dipole moment. So that is P. So how do we find this dipole moment? Dipole moment is magnitude of charge multiplied by distance between the charges. That is the dipole moment. And it is always from negative charge to positive charge. Dipole moment is always from negative charge to positive charge. So how do we say a dipole is a dipole? When two equal and opposite charges are present. Sir, minus 2q plus 2q. Is this a dipole? Yes. Sir, minus 4q plus 2q. Is this a dipole? No. Why? Equal charges are not there. Opposite charges are there, but equal are not. Equal charges are not present. Now, guys, we have to find the net dipole moment in this particular case. Take a look. Take a look. Can I make it something like this? 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 I say this is minus Q and this will be over here plus Q. See, it is 2Q. We can resolve this in two parts, plus Q and plus Q. Plus Q and plus Q will be plus 2Q. Now here also it is minus Q. Minus Q to plus Q. Here this will be the dipole moment P. Because we say in case of an electric dipole, dipole moment is from minus charge to positive charge. Here dipole moment will be from negative to positive. This is also P. Now see, this is an equilateral triangle. So I'll make this dipole moment something like this. I'll make this dipole moment something like this. Angle between the two is 60 degrees. If you have the two vectors, angle between the two vectors is 60. What will be the resultant vector? We say P net in this particular case is root 3 of P. Root 3 of P. What about this? Guys. Can I make this diagram something like this? See. This is we have to find the net dipole moment. This is minus Q. Keep this minus Q as it is. This is minus 3Q. I can write this as plus Q, plus 3Q, plus Q and plus 2Q, plus 2Q. Plus 2Q plus Q will be plus 3Q. And then here it is minus 4Q. It will be minus 2Q, minus 2Q. Minus 2Q is minus 4Q. And here it is plus 2Q. Now you tell me one thing. You tell me one thing in this particular case. See. Can I say here, this is the first dipole, equal and opposite charges. And dipole moment will be from negative to positive. This is the second dipole. Dipole moment is from negative to positive. This is 2P. This is the first dipole from negative to positive 2P. Why am I saying dipole moment is 2P? Because it is 2Q, 2Q. So that's why dipole moment is 2P. Here also it is 2P. Here it is from negative to positive. Here it will be P. Now make the final diagram here. Guys, see, in the downward direction it is 2P. Okay. In the upward direction it is P. And in the left direction it is going to be 2P. Okay. Now, my dear friends, I say 2P minus P will be P. So this will be P. And in the left direction it is going to be 2P. Now, what is the resultant of this one and this one? That is going to be this. And how do you find this P net? I have told you this P net will be, that is under root of this square, that is 2P whole square, that is 4P square plus P square. That is a root 5P. Root 5P will be the net dipole moment in this particular case. Okay. 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 Yes. So guys, let's do one thing. Let's do one thing. Let's take a break. Huh? Get done with the dinner, guys. We say break till 9:40 p.m. Okay. So get done with the dinner quickly, then we will start. Is that clear? Get done with the dinner and then we'll start again. Okay, guys, let's start the session once again. Let's take a look exactly at this particular topic. Electric field at an angle theta from an ideal dipole. Now, guys, see, since when it comes to a dipole, you have got negative charge, you have got positive charge. Okay? Yes. Now, guys, this dipole has got charge in it. So, this dipole is going to create the electric field. Because whenever there is charge, there will be electric field. Now, you have to go at x distance from the dipole at an angle theta. So this is the general point that we are considering. So electric field is going to be, that is Kp divided by x cube under root of 3 cos square theta plus 1. Kp divided by x cube under root of 3 cos square theta plus 1. Okay. Now guys, this is the general point. If I say you go at the axial point, this is the point which we consider the axial point, which lies on the axis of the dipole. So at the axial point, what is going to be the value of theta? Guys, theta is this angle. So when you have to move at the axial point, so we say at axial point, we say value of theta will be 0 degrees. So in that particular case, electric field will come out to be, that is Kp divided by x cube. Then we say under root of 3 cos square of 0. Cos 0 is 1. This will be 3 plus 1 is 4. So this will be 4. Root 4 is, we say, twice Kp divided by x cube. So this is the electric field due to a dipole at its axial point. Okay, that is twice Kp by x cube. And my dear friends, let's suppose if somebody says, what is the electric field due to a dipole at the equatorial point? So this is going to be the theta is equal to 90 degrees. So electric field at this point will come out to be, that is Kp divided by x cube, then under root of 3 cos square of theta. Cos 0 is 1. Okay. Cos 90 is 0. So this will be root 1. Root 1 is 1. So this will be Kp by x cube only. So this will come out to be Kp divided by x cube only. So what I'm trying to say in this particular case, when it comes to the axial point, at axial point, electric field is twice Kp by x cube. And when it comes to the equatorial point, at equatorial point, it will be in the backward direction, opposite direction, minus Kp by x cube. Negative signs represents electric field direction is backward. And when it comes to the general point, this will be the general point, that is Kp by x cube under root of 3 cos square theta plus 1. Like guys, you have a question over here. You have a dipole. This is the dipole. Okay, this is the dipole P. And my dear friends, this is the side L. You have to tell me what is the electric field at point A, what is the electric field at point B. This is the root 2L. Okay. This distance will be root 2L. Now guys, when it comes to the electric field at point A, this is the general point. For general point, we'll be using this formula, Kp divided by x cube under root of 3 cos square of, what is this angle over here? 45. Cos square of 45 plus 1. 3 cos square theta plus 1. Now, this will be Kp divided by, what is the value of x cube? X is this distance. So this is going to be root 2 of L whole cube, 3 cos square of 45. Cos 45 is 1 by root 2. 1 by root 2 whole square. This will be 3 by 2 plus 1. So this will be 5 divided by 2. This is Kp divided by root 2 L whole cube. And this will be under root of 5 divided by 2. Okay. Further also, you can basically solve it. See, this is root 2 whole cube into root 2. So it is root 2, okay, time whole raised power 4. This will come out to be 4 only. Okay. Okay. Why? Because root 2 into root 2 is 2. 2 into 2 is 4. Yes. So we can write it. This will be Kp divided by L cube under root of 5 root 5 by 4. Root 5 by 4. Please do check it from your end only. Okay. Now, then you have the point B. This is the actual point on this dipole. Electric field at point B. Electric field at point B. This will come out to be twice Kp divided by L cube, twice Kp divided by L cube. Yes, yes. Now guys, electric dipole placed in a uniform electric field. Guys, if this is the uniform electric field over here, and if you have placed a dipole in this uniform electric field, directly remember, whenever you place the dipole in the external electric field, we say torque will be created. Guys, this is the positive charge. On the positive charge, force will be experienced in the forward direction. On the negative charge, force will act in the backward direction. So due to these two charges, it will try to rotate. If this is trying to rotate, we say torque will be produced. Whenever there is rotation, there is torque. And that torque will be Pe sine theta. P is the dipole moment of the dipole. Okay. E is the electric field. Theta is the angle between P and E. Theta is the angle between P and E. Theta is the angle between P and E. Okay. Now guys, let's suppose if I say theta is equal to 0 degrees. In that case, how much will be the torque? So theta is equal to 0 means dipole moment and angle electric field are in the same direction. So in that case, torque will come out to be Pe. I'll write over here. Torque is, that is Pe sine theta. Pe sine of 0. Sine 0 is 0 only. So torque in that case will be 0. And if I say theta is equal to 90 degrees, in that case, we say Pe sine 90. Sine 90 is 1. So I can say this is going to be the maximum torque in that particular case. Okay. Okay. Yes. One more important thing. What is that? That is potential energy stored in the dipole in a uniform electric field. See guys, this is the external electric field, and in this you have a dipole. If you are rotating this dipole, means you'll have to do some work. Okay, you'll have to do some work in rotating the dipole and placing it here at an angle theta. So we say on rotating the dipole, you have to do the external work done. I'll have to do the external work done. That external work done is stored as potential energy of the dipole. Or due to that external work done, potential energy of the dipole is changed. Now here, can I write the same statement over here? Work done is equal to change in potential energy. If you do the work done in rotating the dipole, we say that will be stored in the form of potential energy of the dipole. Work done is equal to change in potential energy. Even you can write it like this. So external work done is going to be U final minus U initial. External work done is going to be U final minus U initial. Okay. External work done is going to be U final minus U initial. Now guys, let's suppose if I say theta is equal to 0 degrees. In this particular case, guys, and one more thing. Sir, due to the work done, potential energy is changed. Now, if somebody says, at this angle, how much is the potential energy stored? You'll be saying potential energy at angle theta is minus Pe cos theta. Okay, P is the dipole moment, E is the electric field. You can also say it is minus P dot E. You can also say it is minus P dot E. Now guys, let's suppose if electric field is this, and this is the dipole moment. Okay, this is the dipole. Dipole moment is upward direction, means this is negative charge, means this is positive. What is the dipole? What is the potential energy? U is equal to minus Pe cos of theta. This is cos 90. Cos 90 is 0. So U will be equal to 0. So means when dipole is making 90 degree with the electric field, in that case potential energy is 0. Here. This is the dipole moment in the forward direction. Electric field is also forward. U is equal to minus Pe cos of 0. Here theta is equal to 0. Cos 0 is 1. U will be equals to minus Pe. Okay. Yes. What about this one? This is the dipole moment in the backward direction. Electric field is forward. We say U is equal to minus Pe cos of 180. Cos 180 is -1. So minus into minus plus. So U will be equals to plus PE. In this case, dipole potential energy is positive. So we call this as maximum potential energy, and we call this as minimum potential energy. This is the maximum and this is the minimum potential energy, like it is mentioned over here. Take a look, guys. See, when the dipole is something like this and electric field is this, theta is 90, we say net force here is 0. Torque is PE sine 90. Sine 90 is 1, so torque will be maximum, that is PE. When it comes to the potential energy, that is going to be 0. And if it is placed something like this, guys, in this case, torque will be PE sine 0. So that is torque will be 0 in this particular case. But when it comes to the potential energy, this will be minus PE. Okay, it is also called stable equilibrium. Okay, or minimum potential energy. Similarly, when it is opposite, something like this, here torque will be 0. It is unstable equilibrium, potential energy will be maximum. That is what we have discussed. Now, guys, see. If, for example, you have got two charges, Q1, Q2, and distances R. If somebody says, sir, does here also potential energy exist between the two charges? Yes. Whenever you see two charges from now onwards, you say potential energy exists between the two charges. And that potential energy is KQ1, Q2 divided by R. This is the potential energy between the two charges, that is KQ1, Q2 by R. Like this is the question. If they ask you to tell me, what is the potential energy of the system? Potential energy, we say, exists between the system of charges. See. You first have to check how many number of pairs are there. One pair, second pair, third pair, fourth pair, fifth pair, sixth pair. See, when it comes to the net potential energy between these two, K, Q1, Q2, K, Q square divided by distance between the two is L. Now, this is the first pair, second pair, third pair, fourth pair. So, this is 4 times KQ square by L. Then we say plus. Potential energy between this and this, that will be K, Q square divided by root 2 L. Now, how many diagonal pairs? 1 and 2. So, 2. So, this is going to be the net potential energy in this particular case. This is going to be the net potential energy in this particular case. Okay, there was a question which was asked in Neet 2022. This was the question which was asked in Neet 2022. 6 charges, plus Q minus Q, plus Q minus Q, minus Q plus Q minus Q are fixed, okay, like this, are fixed at the corners of a hexagon of side D as shown in the figure. The work done in bringing the charge from infinity to the center. So there was a charge which was placed at infinity, Q0. We have taken this from infinity to center. So when you have to take the charge from infinity to center, you will have to do the work done. Okay, we have to find how much amount of work we are supposed to do. Always remember, work done is change in potential energy. Always remember, it is going to be final potential energy minus initial potential energy. Finally, charge is at center, initially at infinity. So we say when potential energy is at infinity, charge is at infinity, potential energy is going to be 0. Because we consider potential energy at infinity as 0. We consider it 0. When finally charge is here, tell me what is the potential energy. Sir, this is the pair that is being made. Okay, this is the pair that is being made. This is the pair that is being made. Potential energy between these two. Potential energy between these two, between these two, between these two, between these two, between these two. So we say finally charge is at, when it comes to the final potential energy. Guys, potential energy between this and this. KQ0. KQ0 divided by, if the side is D, this distance will be also D divided by D. Now, if you check this one, this pair, if you check this pair, if you check this pair, don't you think all the three are similar? So I'll be writing over here 3 times. Then guys, if you check this pair, and this pair, these 3 are similar. Now this will be here, one charge is negative, so you'll have to take the negative charge. 3 times k q q naught divided by d. This and this will cancel. U final will be also 0. Now if I say what is going to be the work done, that is 0 minus 0. 0 minus 0, that will be 0. That will be 0 minus 0 is 0. Is this clear? Which option? Even if some students say, sir, we have to consider the potential energy of this system also. Even if you consider that, that will be also cancelled. Net will come out to be 0. Potential, electric potential, electrostatic potential. Take a look. Guys, when it comes to the electrostatic potential, we say electrostatic potential is nothing but potential energy per unit charge. Okay. So it is the potential energy of unit charge. See. We say, here we discussed, sir, if you have one charge, if you have another charge, distances r. What is the potential energy between the two? K, Q1, Q2 by R. If I say one charge is Q, another charge is 1 Coulomb. It is 1 Coulomb. Now, how do you define potential energy over here? K, U is equal to K, capital Q, small q, that is 1 divided by R. Now, this potential energy is K, capital Q divided by R. This potential energy between 1 Coulomb charge and this is what we call the potential. We represent it with V. So potential is nothing but potential energy per unit charge. Even you can write it something like this. U is equal to potential. See. Potential is potential energy per unit charge. Okay. Now see, we can say V is equal to, how do we write potential energy? K, capital Q, small q divided by R. Then divide by this Q. Then divide by this Q. Q will cancel. V will come out to be KQ divided by R. Okay. Now take a look at this question. Okay, see. From now onwards, you'll be remembering that. Let's suppose you have a charge Q at R distance. You have a charge Q at R distance. Sir, what is the potential of this charge? We say V is equal to KQ divided by R. KQ divided by R. This is the potential energy of charge. Let's suppose you have a charge over here. At R distance, we say electric field is going to be, that is KQ divided by R square. This is the electric field. This is going to be the potential. Okay. Now guys, let's take a look. If you have got infinite number of charges, you have to find the net potential at this origin. When it comes to the net potential at the origin, guys, see, potential due to first charge, it will be KQ divided by 1 KQ by R. This is at 1 meter distance. Then plus, what is the potential due to second charge? KQ divided by 2 KQ by R, because this is at 2 meter distance. Then we say KQ divided by 4. This is at 4 meter distance. Then we say plus KQ divided by 8 plus so on. Now guys, when it comes to the net potential, you say this is KQ, and then if you take KQ common, it is 1 plus 1 by 2 plus 1 by 4 plus 1 by 8 plus so on. Now guys, how can we find the sum of this? Sum of this will be A upon 1 minus R. Okay. And here A is the first term. And how do you find the common ratio? Tell me, sir. Take any term, 1 by 4, divide with it a term which comes before it, 1 by 2. 2 ones are, 2 twos are, so it is 1 by 2. Now find the sum, 1 upon 1 minus 1 divided by 2. 2 into 1 is 2, 2 minus 1 is 1 by 2. It is 1 upon 1 divided by 2, so this will come out to be 2. So I can write over here, when it comes to the V net, it will be KQ, and instead of all of this, I'll be writing over here, that is 2. So that is 2 times KQ. Is this clear? Is this clear? Is this clear? Okay, tell me. Guys. When it comes to the potential, it is a scalar quantity. When it comes to the electric field, it is a vector quantity. Always remember this. Now tell me, you have got the four charges. You have to tell me what is the electric field at the center. See. Electric field due to this positive charge at the center will be away from the charge. Due to this positive charge, it will be away from the charge. Due to this positive charge, it will be away from the center. Due to this positive charge, it will be away from the center. This will cancel with this one. This will cancel with this one. I can say net electric field at the center is 0. I can say net electric field at the center is 0. Net electric field at the center is 0. Okay. But sir, when it comes to the net potential, guys, see. Always remember net potential. If let's suppose side is L, how much is going to be this distance? This will be L divided by root 2. Now, what is the potential due to this charge at the center? Guys, see. It is KQ divided by this distance, that is L by root. Now, how much will be potential due to this at the center? KQ divided by L by root 2. KQ divided by L by root 2. KQ divided by L by root 2. So, this is 4 times. So, it will come out to be 4 root 2 KQ divided by L. Sir, does this potential has a direction? No, because it's a scalar quantity. That's why we are directly adding it. But when it comes to the electric field, we are mentioning the direction also. It is getting clear. Okay. Yes. Now take a look. Here, potential due to a hollow and solid sphere. Potential due to a hollow and solid sphere. Hollow conducting and solid non-conducting. If let's suppose you have got a sphere over here. Okay. And radius of this sphere is given as capital R. And you have to find the electric field. Sorry, you have to find the potential at small r distance. Okay. That is outside. You have to find the potential on the surface. You have to find the potential inside. Guys, outside it is going to be KQ. Q is the charge on the sphere. Small r is the distance at which you have to find the electric field. Okay. Yes. When it comes to the surface, if you keep on moving towards the surface, on the surface we say value of small r will be equals to the capital R. So value of small r is equal to capital R on the surface. So KQ divided by capital R. When it comes to inside, guys, always remember inside. Whatever is the potential on the surface, same will be inside. KQ by capital R. Whatever is the potential on the surface, same will be inside. Now, guys, see. In this case, inside, K is constant, Q is constant, R is constant. Inside is constant, K is constant, Q is constant, capital R is constant. So, till surface, it is constant. If you have to make the graph, graph between V versus R, can I say inside till surface potential is constant? Yes. And outside we say V is inversely proportional to R. And this will be the surface where small r is equal to capital R. This is inside and this is outside. Now take a look, guys. Potential due to a solid sphere. This is a solid sphere. Solid sphere means in which charge is present inside also. You have to tell me the potential outside the sphere at small r distance. You have to tell me the potential on the surface. You have to tell me the potential inside. When it comes to the outside point, potential will be KQ divided by small r. Small r is this distance outside. When it comes to the surface, it will be KQ divided by capital R, because on the surface value of small r is equal to capital R. When it comes to inside, you have to remember this formula. that is kq upon 2r cube multiplied by 3r square minus small r square. Small r is the distance inside where you have to find the potential. Capital R is the radius. Okay. Now, what I want you to understand here is, we say, if let's suppose I'm saying how much is the potential at the center, what will be the value of small r at the center? That will be 0. So if this term is 0, then it becomes 3r square r cube. R cube and square will cancel. So this will become 3 by 2 kq by r. So this will be the potential at the center, 3 by 2 kq by r. This is the potential at the center exactly. This is the general formula inside. This is out. This is on the surface. This is outside. Now, if somebody says how to make the graph, see guys, when it comes to the potential on the center of a solid sphere, 3 by 2 kq divided by r. When it comes to the surface, it is kq divided by r. Now see, 3 by 2 means 1.5 kq divided by r. Can I say 1.5 is greater than 1? Potential on at the center is greater than potential on the surface. Now, this is the center where value of small r is equal to 0. On the center, value of small r is equal to 0. Okay. So, my dear friends, at the center, can I say potential is maximum? How much? 3 by 2 kq by r. This is V naught. And then potential decreases, reaches surface. So this is surface where value of small r is equal to capital R. So at the surface, potential is going to be kq by capital R. Then this is outside. Outside, we know potential is inversely proportional to small r. This is inside. Okay, this is outside. It is inversely proportional to small r. Is this clear? Please give me the signal in the chats. And smash the like button, guys, if you have not liked the session yet. Okay. Find V net and E net at A, B, C. At A, B, and C. You guys are supposed to find the net potential and net electric field at A, B, and C. Okay. My head is, I'm having the headache, guys. A lot. Now see, take a look. Find net potential and net electric field at A, B, and C. Guys, see, when it comes to the point A is outside of this sphere also, point A is outside of this sphere also. Okay. Now, if you have to find the electric field at A, outside the sphere, electric field is kq by r square, small r square. Okay, kq by small r square. So I can say it is going to be, sir, k due to this bigger sphere, it is going to be kq1 divided by, at what distance? Small r, that is ra square, plus due to small one, kq divided by ra square. Okay. Due to this charge, it has got the charge q2 on it, kq divided by ra square. Due to this one, kq divided by ra square. So you can write it k divided by ra square, then you can say q1 plus q. Okay. When it comes to the electric field at point B, guys, see, this is the point B. Point B is the inside point of this. This is a hollow sphere. Okay. So electric field at B, due to the outer sphere, it will be 0. Why? Because it is the inside point. In case of the hollow sphere, in case of the hollow sphere, electric field inside is 0. And we say due to this inner sphere, for the inner sphere, point B is the outside point. So electric field is going to be, that is K, we say Q2 divided by, it's at what distance from the center? That is RB square. Okay, I hope this is clear. Then when I say electric field at point C is inside of this sphere, so it is going to be 0 plus 0, that is 0. Electric field at C is 0. When it comes to the net potential, guys, let's talk about potential at A. See, guys, A is the outside point of bigger sphere, smaller sphere. So potential at outside point is KQ by R, small r. So it is going to be KQ1 divided by RA. Due to bigger sphere, it is going to be KQ1 divided by RA. Due to smaller sphere, it is going to be KQ divided by RB. So I can say this will be K divided by RA only. K divided by RA, then we say Q1 plus Q2. When it comes to the potential at B, at point B, we say potential due to C. In case of a hollow sphere, if you remember, I have told you here, whatever is the potential on the surface, same will be inside. So here, whatever is the potential on the surface of this bigger sphere, same will be inside. So what is the potential on the big surface? KQ1 divided by its radius, that is R1. Okay. Now this point is outside of this sphere. So it will be KQ2 divided by this distance, that is RB. Okay. Then if we talk about point C, potential at point C, it will be sir, potential due to the bigger sphere, that is KQ1 divided by, guys, whatever is the potential on the surface of the bigger sphere, KQ1 divided by R1 plus, that will be inside at every point. And whatever is the potential on the surface of this sphere, that is going to be KQ2 divided by R2, that will be inside also. Whatever is the potential of this sphere on the surface, that will be inside. Whatever is the potential of this sphere on the surface, that will be inside. Please do check this later on from your end if you are getting any sort of confusion in this one. This is a very good question. Very important. Now, guys, take a look. Here in this particular case, what does it say? Electric potential due to a charged ring. You have got a ring over here. Okay, Radius of the ring is, we say, R. You have to tell me potential at point P. Directly remember, potential at point P due to the ring will be KQ upon under root of R square plus X square. Okay. Yes, under root of R square plus X square. Now guys, listen. Listen to me very carefully. Let's suppose if I say, what is the potential at the center of the ring? At center, what is the value of X? That is 0. At center, value of X is 0. At center, what is the value of X? That is 0. So potential is going to be, that is KQ upon under root of X will be 0, root R square. This and this will cancel, that is KQ divided by R. Okay, yes. Now, if I say very far from the ring, let's suppose you are not finding the potential here, you are finding at very far distance, okay, such that X is much greater than capital R, such that this X is much greater than capital R. In that case, potential will be, that is KQ upon under root of, guys, if X is much greater than capital R, so means this is a very small quantity. Adding a very small quantity to a very large quantity will not create any difference. So you can ignore this r. So you can directly write x square, square and root will cancel. It will be kq divided by x. Okay. So potential at very far distance from the ring is kq by x. Potential at the center is going to be kq by r. Let's take a look at the question. Let's take a look at the question. Let's take a look at the question. See guys, you have got two rings over here, this one and this one. You have to find VA minus VB, means you have to find the potential at this point. You have to find the potential at this point B. First and the foremost thing, if I say what is going to be the potential at A, potential at point A will be the potential due to this ring, because both have got the charge. Now guys, A point is the center of this ring. What is the potential due to this ring? So it is going to be kq divided by, it is the center, so we say kq by r, because potential at the center is kq divided by r. Okay. Then we say potential due to this ring minus, we say kq divided by. So if we talk about point A is at what distance? X distance from the sphere. So it is going to be kq divided by x. Similarly, if I talk about potential at B, so due to its own charge, due to this sphere, due to this ring, potential at center will be minus kq divided by r. Due to this, it is going to be plus kq divided by x. Plus kq divided by x. Okay. Now you have to find VA minus VB. VA minus VB. You'll be writing that is kq divided by r minus kq divided by x. Okay. Then you will be writing minus, this is kq divided by r. Then we say plus kq divided by x. Yes. Now guys, this is kq divided by r minus kq divided by x minus kq divided by r plus, minus kq divided by x. So. Did I make any mistake? VA minus VB kq. This is minus kq by x. Minus kq by r. This minus kq by r. Minus into minus, this becomes. So this will be 2 times kq divided by r minus 2 times kq divided by x. So 2 times kq you can take common, 1 divided by r, 1 divided by x. This is the final answer. This is the final answer. Then you have the last topic from this particular chapter, that is going to be equipotential surfaces. Now guys, take a look. Equipotential surfaces. Equipotential surfaces. We say that surface upon which potential is same everywhere is called an equipotential surface. Like. Guys. Let's suppose I'm saying I have got a charge over here. Okay. If I say, sir, at r distance, how much is the potential? Kq divided by r. This is the potential due to a charge at r distance. If I say from this side, it will be KQ divided by R. If I say from this side, it will be KQ divided by R. If I say from this side, it is KQ divided by R. So basically, if this is a charge, at R distance KQ by R, 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 at R distance KQ by R. Now, what if I say in this particular case, I am joining all of these points, spherical points? Can I say if I take this point and this point, this is point A, this is point B, can I say potential at A is equal to potential at B? Yes. So we say this surface will be considered as an equipotential surface. So for a point charge, the equipotential surface will be considered as the spherical surface. So that surface upon which potential is same everywhere is called equipotential surface. The difference between the 2 points on the equipotential surface, the potential difference between the 2 points on equipotential surface is 0. Obviously, if potential at A was KQ by R, at B was also KQ divided by R, this and this will cancel, it will be 0. Okay. Now guys, electric field is perpendicular to equipotential surfaces at all the points. Now guys, see. This is the charge. Due to the charge, electric field is away from the charge. This is the equipotential surface. How much angle it is making? 90. Here 90. Here 90. And this point was asked in NEET 2022. This point was asked in NEET 2022. Okay. No work is done by the electric force in moving the charge on an equipotential surface. Guys, we say, how do we write the work done? That is change in potential energy. If you remember, I say divide the charge Q, divide the charge Q. Work done will come out to be, guys, work done by charge. Potential energy per unit charge is potential, delta V. So work done is going to be Q delta V. Now, what is the potential difference on equipotential surface? 0. So 0 multiplied by this will come out to be 0. That is what it is saying. No work done. Work done will be 0 if you move a charge from one point to another point on an equipotential surface. Why? Because potential difference is 0. Okay. So that's all for chapter 1. This is the chapter 2. Is that clear? Tell me. Just a second, guys. Head is paining a lot. Oh. Okay. So we have this chapter, capacitors. We have this chapter that is capacitors. Now, guys, what is a capacitor? What is a capacitor? We say capacitor is a device which is used to store electrical energy. Okay. Now guys, you have a bucket. Bucket is a device which is used to store water. Similarly, capacitor is a device which is used to store electrical energy. As simple as that. Now guys, let's suppose you are taking a spherical capacitor over here. Okay, spherical conductor capacitor which is having the radius r. Now you are storing the charge q on it. Due to the charge, potential will be developed, because we know potential on the surface of the sphere is kq divided by r. It is going to be kq divided by capital R. Okay, kq divided by capital R. Now guys, we say when it comes to the potential on the surface of the sphere, it is V is equal to kq divided by capital R. We say potential is directly proportional to charge. V is directly proportional to charge. More we store the charge on the sphere, on this capacitor, more will be the potential. Okay. So we say Q is directly proportional to V. Replacing this proportionality with the constant, we say C, where C is the constant and is called the capacitance of a capacitor. Okay, where C is the constant and C is called capacitance of the capacitor. So this C is the capacitance. Capacitance means how much is the capacity of a capacitor to store the charge. Sir, capacitance of a capacitor is large, means you can store large amount of energy. Capacitance of a capacitor is small, you can store small amount of energy. Okay, now guys, see. If I say over here, tell me the answer of this question. We say Q is equal to CV. C is equal to Q divided by V. Does capacitance depend upon charge? Does capacitance depend upon potential difference or voltage? Tell me. We say capacitance does not depend upon charge. It does not depend upon voltage. Because capacitance is constant. It is a constant. It is constant. See, it is like, let's suppose you have got a bucket. Okay. I am saying more you store water in this bucket, its capacity will increase. Is this logical or illogical? It's illogical. Sir, you can store the limited amount of water over here. If you send more water, it will overflow. It will come out. So due to the increase in water, we say capacity cannot increase. Similarly, if this is a capacitor, if you store charge in it, due to storing charge, how is it possible that its capacity will increase? So capacitance does not depend upon charge or voltage. So let's talk about this capacitance of a spherical capacitor. We say capacitance of a spherical capacitor is 4 pi epsilon naught R. It is 4 pi epsilon naught R. This capacitance depends upon the radius. This capacitance depends upon the radius of a capacitor. Capacitance depends upon the radius of a capacitor. Capacitance depends upon the radius of a capacitor. Okay. Capacitance depend upon the dimensions. This is the capacitance of a spherical capacitor. Now guys, there is an important question which can be asked from this particular topic. There is an important question which can be asked from this particular topic. See. Question is, n small capacitors are combined together to form a big capacitor. Sir, how this process done? We don't have to talk about that. Combined together, if they are joined together, means they are joined together. We have to agree with that. So we say n small capacitors are combined together to form a big capacitor. Okay. When it comes to these small capacitors, charge on small capacitor is small q, potential is V, capacitance is C, radius is small r. Now guys, we say when it is formed a big capacitor, potential of the big capacitor is V dash, capacitance is C dash, radius is capital R, charge is Q. If they ask you to tell me how much is the charge of the big capacitor after joining n capacitors, we say Q will be equals to n times of small q. Okay. We say radius will be equals to n raised power 1 by 3 into small r. Okay. N means how many number of capacitors? I'll show you the question also. C dash will be n raised power 1 by 3 into capacitance of a small capacitor. V dash potential will be n raised power 2 by 3 into V. Let's take a look at the question. This question was asked in Neet 2023. See, 27 small drops. So means you have got how many small drops? We say n is equal to 27 small drops or capacitors. It's one and the same thing. Are combined together to form a big drop. Okay. Of 27 small drops of same size are charged at 220 volts. Means potential of this is given as 220 volts of each capacitor. They are combined to form a big drop. You are supposed to find the potential of the big drop. Now see, when it comes to the potential of big drop, guys, V dash will be equals to directly n raised power 2 by 3 into V. We'll be writing n raised power 2 by 3 into V. V dash will be equals to, what is the value of n? N is 27. This is 27 whole raised power 2 by 3 into V. And this is how we are going to write it. Okay. Okay. Now 27, can we write it like this? V dash will be equals to, guys, this is 27 whole raised power 1 by 3 and then whole raised power 2. It's one and the same thing. Once again you multiply, it will become that only into V. So cube root of 27 is 3 into 3 into 3. 3 into 3 is 9, 9 into 3 is 27. So V dash will come out to be 3. Value of this is 3 square. 3 square is 9. That is 9. 9V. V is 220. So it will come out to be 1980 volt. 1980. Even if they ask you to find the capacitance of the big drop also, how do you find C dash? N raised power 1 by 3 into C. We'll be writing n raised power 1 by 3 into C. So C dash will be n. N is given as how much? That is 27 raised power 1 by 3 into C. C dash will be 27, that is 3C. Capacitance is 3C. Even you can find capacitance, voltage, you can find radius also. Radius will be also 3R. Okay, R will be also 3R. Is this clear? Please tell me in the chats. Is this clear? Please tell me in the chats. So from now onwards, if you face any sort of question, and this is very important, now take a look, guys. You have got the parallel plate capacitor. Till now we were discussing the spherical capacitor. Okay. Parallel plate capacitor means you have got two plates parallel to each other which has some area A. Separation between the plates is D. This forms the parallel plate capacitor. Okay. Sir, which one is better? Parallel plate or a spherical? We say parallel plate. Why? Because here, when it comes to the parallel plate capacitor, we say energy is stored between the plates of the capacitor, okay, between the plates of the capacitor. Now guys, energy is stored between the plates of the capacitor. So we say energy, there are less chances that energy will be leaked out. Now, what is the capacitance of this epsilon naught A divided by D? Capacitance of parallel plate capacitor is epsilon naught A by D. A is the area of the plates, D is the separation between the plates. Take a look. This was the question which was asked in Neet 2022 from this one. Find the capacitance of the capacitor if the area of the plates is A by 2, separation is 2D. See guys, you have a parallel plate capacitor, okay? This is the parallel plate capacitor. This is the parallel plate capacitor. Its capacitance is epsilon naught A divided by D. Its capacitance is epsilon naught A divided by D. Okay. Now guys, then further it says, when its area A dash becomes A divided by 2, when its distance separation becomes 2D, we say capacitance C dash will be epsilon naught A becomes A by 2 and D becomes 2. D dash becomes 2D. C dash is going to be epsilon naught A upon 2 into 2 is, we say 4. Okay. I hope this is crystal and clear. I hope this is crystal and clear. Epsilon naught A divided by 4D. Okay. And it becomes C by 4. So this capacitance C dash becomes C by 4. Okay. The energy stored in the capacitor. Okay, first let's talk about the energy. See guys, since we spoke that, sir, capacitor is a device which stores energy. How much is the energy stored in the capacitor? We say U is equal to Q square divided by 2C. U is equal to Q square divided by 2C. Guys, we say as Q is equal to C into V, I'll write over here C square V square divided by 2C. This and this will cancel. It will come out to be 1 by 2 CV square. That is mentioned over here. In terms of charge and capacitance, this is the formula. In terms of capacitance and voltage, this is the formula. And then further, in terms of charge and voltage, this is the formula. Okay, okay, you can remember all the three equations. Now, here, take a look. A capacitor is of capacitance 700 picofarad, okay, is charged by a 100 volts battery. The electrostatic energy, just formula based, U is equal to 1 by 2 CV square. This is given as 700 picofarad, V is given as 100, put the values and get the answer. Okay. Force between the plates of the capacitor. Force between the plates of the capacitor. See guys, we say this is the plate over here. This is the plate over here. Listen to me very carefully. Listen to me very carefully. When this battery, let's suppose this is the plate over here. When this battery is connected to the plate, this is the positive terminal of the battery. Always remember, this battery takes the charge from one plate and places onto the another plate. If positive charge is occupied on this plate, negative will be occupied on this plate. Or this will occupy positive on this plate, and due to this, negative charge will be occupied onto this plate. Okay. Now, you have got a parallel plate capacitor. We say one plate of the capacitor is positively charged, another plate is negatively charged. Now, this positively charged plate and negatively charged plate, don't you think they will attract each other? Okay, this will attract it with the force F, this will attract it with the force F. So we say two plates will attract each other because of the opposite charges. To find that force, we say that force is Q square upon 2A epsilon naught. Q square upon 2A epsilon naught. Okay. And then we say this force in terms of sigma, it is sigma square into A divided by 2 epsilon naught. In terms of sigma, charge per unit area. Okay. Okay. So this is in terms of charge, this is in terms of sigma. Now take a look at this question. Take a look at this question. Take a look at this question. The electrostatic between the plates, between the metal plates of an isolated parallel plate capacitor having charge Q area A. Yes, see. When it comes to the force, we say force is equal to Q square upon 2A epsilon. According to the question, yeah. Now you tell me one thing in this particular formula. So according to the question, we say charge is given, area is given. So force between the plates will be this. Now, is there any distance that you can see? Is there any separation? We say, is there separation in this particular formula? No. Separation between the plates is not mentioned in this formula. So I would say this force is independent of the distance between the two plates. Independent of the distance between the two plates. Now take a look, common potential. Let's talk about common potential. Let's talk about common potential. See guys, when it comes to the common potential, I want you guys to understand one thing. What is that? See. You have got a capacitor over here that is C1. We say this is its first end. It has got potential V1. So there is a capacitor. The potential of this end is V1. Okay. You have got another capacitor C2. Its potential here is V2. You have got another capacitor C3. Here potential is V3. And this is the center. Here, this is the common point. Potential of this common point. If I say potential of this common point, it will be C1 V1, C1 V1, C2 V2, C3 V3 upon C1 plus C2 plus C3. This is how we find the potential of the this is also called midpoint potential. Okay. Midpoint potential or the common potential. Now guys, take a look. Let's suppose you are given a question something like this over here. Find the charge in 4 microfarad capacitor. You have to find the charge in this 4 microfarad capacitor. Take a look. Whenever you have questions something like this, I want you to understand one thing. Assume 0 volt potential at a point. Assume 0 volt potential at a point. Sir, does it make any difference? It will not make any difference. Assume 0 volt potential at this. Yes. So when you are mentioning 0 volt potential at this point, listen to me very carefully. Guys, let's suppose this is a battery. Always remember, I'll show you. This is a battery. Okay. This is a battery. This battery is having voltage of 20 volts, potential difference. This is called delta V. This point is what we call point A, or this is another end B. Always remember, potential of this minus this. VA minus VB. This is the higher potential, positive terminal, higher potential, lower potential. Always remember. Okay. Always remember, VA minus VB is delta V. This potential minus this potential is always equal to delta V. So here VA minus VB is equal to 20 volts. Okay. Now guys, take a look at this battery. In order to solve this problem, what you guys are supposed to assume 0 volt potential at a point. Now, could you please tell me what will be the potential of this end? See. I'll make this battery over here. This is 20 volts. Here it is 0 volts. This is potential A. Can I say this potential minus this potential, VA minus 0, must be equal to 20? So VA will come out to be equals to 20. So what I'm trying to say is that potential of this end will be 20 volts. Similarly, if this is 0, what will be the potential of this end? That is going to be 10 volts. 10 minus 0 is 10. Now guys, this is a straight wire going till here. Here also potential is going to be 10 volts. This is a straight wire. It's 20. So here also it is going to be 20 volts. it is a straight wire. Here also it is going to be, we say, plus 20 volt, plus 20 volts. Okay. Now guys, redraw this figure, redraw this figure. Listen, listen. So I'll redraw it something like this. Okay. This is 5 microfarad. This is 4 microfarad. This is 1 microfarad. Potential of this end is, we say, plus 20 volts. Potential of this end is plus, is 10. It is 10 plus 10 volts. Potential of this end is 0 volts. First find the potential of midpoint. Potential of this midpoint. Okay, you have to first tell me potential of the midpoint. Okay. Okay. Now guys, take a look. Take a look. If you have to find the potential of the midpoint, how do you find? Sir, V1, C1, V1. C1 is 5, V1 is 20. C1, V1. So 5 into 20. Then we say plus C2, V2. C2, V2. 4 into 10. 4 into 10. Then C3, V3. C3 is this 1 into 0. Plus 1 into 0. Then we say upon C1 plus C2 plus C3. That is 5 plus 4 plus 1. Now 5 into 20 is 100. 4 into 10 is 40. Upon 5 plus 4 is 9. 9 plus 1 is 10. So it is going to be 140 divided by 10. So this will come out to be 14 volts. Means potential of this is 14 volts. Guys, remember, see. So you got the midpoint potential at 14 volts. Now, you have to find the charge in 4 microfarad capacitor. Take this 4 microfarad capacitor. This is 4 microfarad. What is the potential of this end? Okay, potential of this end, that is plus 10. So it is going to be plus 10 volts. What is the potential of this point A that we got? That is 14 volts. Now, if I am asking you the simple question, how much is the charge? You say Q is equal to C into V, delta V or V, it's one and the same thing. This V actually is the potential difference. Now you tell me. So this Q will come out to be C into delta V. And what is C? C is over here 4. Delta V is higher potential minus lower potential. That is 14 minus 10. That is 4. 4 into 4 is 16. So Q will come out to be 16 microcoulomb. So basically, if you want to find out the charge in a capacitor, you must know the potential across the ends of the capacitor. Sir, can we find the potential in this? Yes. Take this capacitor. It is 5 microfarad. Here it is 20 volts. Here it is 14 volts. So Q is equal to C into delta V. So C is 5. Delta V is higher minus lower. 20 minus 14. 20 minus 14 is 6. 5, 6 are 30. So Q will come out to be 30 micro. Is this clear? Dielectrics in capacitors. Okay, guys, see. This is the plate of a capacitor, positive plate, negative plate. You are placing a material, namely dielectric material. Like you have conductors, you have insulators, similarly you have dielectrics. These are the 3 different materials that you have: conductors, insulators, dielectric you are placing. It has got positive charge as well as negative charge. Now guys, listen to me very carefully. When you place this dielectric, you say positive charge of this plate will attract the negative charge of the dielectric towards itself. Negative charge of the plate will attract the positive charge of the dielectric towards itself. After some time, we say negative charge will be occupied on the left wall of the dielectric. Positive charge will be occupied on the right wall of the dielectric. Negative charge will be occupied on the left wall of the dielectric. Positive charge will be occupied on the left wall. Negative will be on the left, positive will be on the right. Now guys, what is the charge on the plates? That is Q, capital Q. how much charge got induced here, that is Qi. If somebody wants ask you, what is the value of this Qi which got induced on the walls of the dielectric? Qi is equal to Q into 1 minus 1 divided by K. Q into 1 minus 1 divided by Q into 1 minus 1 divided by K. Okay. Q into 1 minus 1 divided by K. Okay, what is K? K is the dielectric constant of this dielectric. And if somebody says, what is the value of sigma? Charge per unit area. Okay, sigma will be Q charge divided by area. Area will cancel. Sigma into sigma I will come out to be. Sigma into sigma I will come out to be 1 minus 1 divided by K. 1 minus 1 divided by K. 1 minus 1 divided by K. Okay, now guys, one more important topic that I want to ask you over here. What is that? Let's suppose you have got the parallel plates of the capacitor. And in this parallel plates, you are placing a dielectric. You are placing a dielectric in between the plates of the capacitor. And this dielectric is having the width of T. Separation between the plates is D. Separation between the plates is D. Okay. This is having the width T and this dielectric constant is K. Now guys, when dielectric constant is placed in the dielectric, always remember its capacitance changes. So we say whenever a dielectric constant is placed in a whenever a dielectric constant is placed in a whenever a dielectric is placed in a parallel plate capacitor, its capacitance changes. Its capacitance change. Okay. And guys, here. If the width of the dielectric is T, separation between the plates is D, this will be the capacitance of the capacitor. Epsilon naught A upon D minus T plus T divided by K. Epsilon naught A upon D minus T plus T divided by K. D is the separation, A is the area of the plates, T is the width of the dielectric. T is the width of the dielectric. Okay. Now guys, if you have a plate, another plate, between the plates, multiple dielectrics are placed. 1, 2, 3, 4. Its dielectric constant K1, K2, K3, K4. This separation D1, D2, D3, D4. Here if somebody says what is going to be the capacitance after placing the multiple dielectrics, this one. Epsilon naught A D1 by K1 plus D2 by K2, D3 by K3, D4 by K4. This is also called series combination of dielectrics. Now see, there was a question which was asked in J Mains 2021 on the same. You have to tell me the net capacitance of this. So this will be epsilon naught A upon D1 by K1. D1 is D, this is K, D divided by K, then plus D2 by K2, that is 2D divided by 3K. Okay, then plus we say 3D divided by 5K. So C will come out to be epsilon naught A upon. Now guys, here you can take D divided by K common. It will be 1 plus 2 by 3 plus 3 divided by 5. Okay. Now this will come out to be epsilon naught A upon D divided by K. This will come out to be 34 divided by 15. Now this 15K you can take in the numerator. C is equal to I can write 15 divided by 34 epsilon naught A into K divided by D. 15 by 34 epsilon naught A into K divided by D, option 1. Okay. Let's suppose, let's suppose this dielectric of width T is a conductor. Always remember, for conductor we consider K is equal to infinity. Same formula I am using which I have told you previously, but here instead of K I'll be using infinity. So something by infinity, 0, that will be epsilon naught A upon D minus T. So for a conductor this is going to be this one. Now parallel combination of dielectrics, guys. Let's suppose if this is the plate, if this is the plate, if this is the plate, this is another plate, this is another plate. This is dielectric K1, K2, K3, width A1, A2, A3. Here, the capacitance after placing the dielectrics in parallel, epsilon naught A, epsilon naught by D, A1, K1 plus E2, K2, A3, K3. Okay, like here, this is the previous year question. So in this particular case, you have got a parallel plate capacitor in which two dielectrics are placed parallelly. You have to tell me the capacitance. C is equal to epsilon naught by D, A1, K1. A1 is A divided by 2. For air, always remember K is 1. So this will be 1. Then we say A2, K2. A divided by 2 into K2 is K only. So C will come out to be epsilon naught divided by D. Take A by 2 common, then it will be 1 plus K. Now epsilon naught A by D, okay, this is the final capacitance. So epsilon naught A by D is the capacitance of a capacitor without dielectric. C dash will come out to be C divided by 2, 1 plus K. 1 plus K. Okay, one more important thing. If you have multiple capacitors connected in parallel, okay, multiple capacitors connected in parallel, this is how we find the equivalent capacitance. 1 by C equivalent is equal to 1 by C1 plus 1 by C2 plus 1 by C3. Okay, plus 1 by C3. Okay. Now guys, for two capacitors in series, sorry, it's a series combination, I can write 1 by C equivalent is equal to 1 by C1 plus 1 by C2. Do the cross multiplication. 1 by C equivalent is equal to, we can say C1 plus C2 upon C1 into C2. Do the reciprocal. C equivalent will come out to be C1 C2 upon C1 plus C1 C2 upon C1 plus C2. This is for two capacitors. For two capacitors in series. For two capacitors in, okay. If you have parallel combination of capacitors, in that case, this is going to be the capacitance C1 plus C2 plus C3. Simply. Now, this is the question. Find an equivalent capacitance. If they ask you to find the equivalent capacitance. Okay. If they ask you to find the equivalent capacitance, guys, see how you guys are supposed to solve this. This is point A. Here also it is going to be point A. And it's a straight wire tail over here. Here also it is going to be point B. A. It is point B here. Here also it is point B. Straight wire tail over here. This is point B. Sir, why cannot we call this as point B? Because capacitor came in between. If this is a simple wire only, then you can say this. So in order to find the net capacitance of this system, always remember, first is you guys are supposed to mark the points. Since you have marked all the points, then you basically, this is A, This is A and this is B. This is A and this is B. Okay. Then you have to write all those points which are exactly over here. Then you have to write all those points which are exactly over here. Okay. Now, my dear friends, I'll write over here, this is A, and I'll write over here, this is B. Okay. Mark all those points over here. Now, first capacitor is connected between A and B. So, mark it C. This one, C1. Second capacitor is also connected between A and B. So, here also it is C. All capacitors are identical. Third capacitor is also connected between A and B. So, I'll mark it over here. C, C, C. So, I can say C equivalent in this case will be C divided by 3. Okay. Because I can say when the capacitors are connected in parallel, so I can say in that particular case, C equivalent will be C plus C plus C, that is 3C. That is 3. Okay. It looks like they are connected in series, but in reality, they are connected in parallel. This was asked in NEET 2021. See, guys, we say potential, this is A and this is B over here. Okay. Or let's suppose this is Vx potential. From here, it is Vy. Now, guys, it is a straight wire. Here also, potential of this will be Vx, Vy, sorry. Potential of this point will be also Vy. Guys, now tell me, see. If the potential across the capacitor is same, that capacitor will be short circuited. Remove it. Now, how many capacitors are there? This C and this C. From this side, potential is Vx. From this side, now potential is Vy. Now, this C and this C are in parallel. So, C equivalent will be C1 C2 upon C1 plus C2. Okay. So, C square upon 2C. This and this will cancel. C divided by 2 is the answer. So basically, you have to mark the potential. Potential here is, let's suppose, 2 volts. Here also it will be 2. Here also it is 2. If the potential across the ends of the capacitor is same, so remove it, short circuit it. Okay. So we have completed this chapter also. Guys, I don't think I would be able to continue the session because I have a headache. Okay. C and C are in parallel. When it comes to the parallel, no, we do C plus C. That is 2C. That is 2. Yes. Okay, because in resistors, what do? We say in resistors, in parallel combination, we do this. We do R equivalent is equal to R1, R2 upon R1 plus R2. That's why sometimes it is confusing. Okay. Now, guys, see. What I can say in this particular case is, see, I will show you one thing. I have a lot of headache right now. Okay. Just a second. If I search over here YouTube. If I search over here YouTube. Where is my channel? Unacademy Neet English. Take a look. Okay, guys, when you open the channel, you go to the playlists, okay? You go to the playlists. And then you see over here this series, bounce back series. Click onto this bounce back series, okay? Then when you click onto this bounce back series, guys, take a look. Here you have got complete physics 12th part 1. Okay, complete physics 12th part 1. Okay, all the topics which I am teaching you in the today's marathon, all the topics which I am teaching in the today's marathon are completed in this marathon. Okay, you can watch this marathon from you can continue from now on itself. Okay, all the topics. Okay, so this complete physics part 1 class 12th one shot bounce back, and this is just 3 months ago. This is just 3 months ago. Okay, okay, I'll take some rest right now, so please you continue. Okay, you can see the same question which I have shown you recently. Okay, all the topics, everything, and this question from the capacitors which I have shown you. Okay, so you watch this session, it will come, you can complete at 2x, you can watch this session. Okay, okay, so that's all for today. Thank you so much. Please do let me know in the comments when I end the live stream how was the session. Take care and bye bye. See you guys in the next session. Okay, mostly I'll be taking the 11th part 2. Okay, take care. Okay, go with this particular session, cover all the topics. Okay, so it is 11 hour and 54 minutes or 12-hour session, so go with this. Okay, so that's all for today. Do let me know in the comments afterwards how was the session. Take care and bye bye. Thank you so much.